So, hello everybody, and welcome to another live stream here on the TimWeTurby channel, which hasn't been online for a while. I haven't really done much KTANE stuff or even less live streaming in a while, but today we are here with my good friend Quinn Wuest. Say hello.
Hello.
Alright, so Quinn came up with an idea for a module, which is going to be called Decolour Flash, and yes, it is a Color Flash remake. So I'm going to head away from the chat for a while, and I'm going to read out the entire manual. Hopefully you guys will see what this module is about. I just noticed that the flavor text is still the flavor text from Hexamaze, which it shouldn't be. I guess we'll come up with a new one. Maybe you guys have an idea for it. But for now, let's read through this. Decolour Flash. A Decolour Flash module cycles through 3 displays with a break indicating the end of the sequence. Each word color pair refers to a position in the hexagonal grid, in the hexagonal diagram below. The color refers to the color of the cell, and the word refers to the single letter abbreviation in the cell. Note down these 3 positions. These are your goals. Then press either button. The display will then cycle 3 positions with no break. These positions are the vertices of a triangle in the diagram. For example, these are not highlightable. We need to fix that, Quinn. Right, so for example, it might say yellow on green, white on magenta, and green on yellow, or rather in yellow, I should say. So press the No button to remove the currently displayed vertex from the triangle and add the other vertex that would form another triangle with the remaining 2 vertices, thus moving your position in the diagram. So in this example, if you have those 3 squares, if you press the No button while the yellow in green is shown, it will flip over to the yellow in blue, and now this is your triangle. And now if you press it when white in magenta is shown, that will flip over to here, and now you have that triangle. And this way you can navigate through the entire grid. Right? Travel to each of the goals in order and press yes when a goal is displayed. After reaching all 3 displays, travel to the central cell of the diagram to disarm the module. So notably, here we only need to touch the center. We don't need to press yes or no or anything on it. That is because attempting to move off the grid, pressing yes on an incorrect display, or moving to the central cell without submitting all 3 displays will incur a strike, right? So the edge of the board and the center cell of the board are taboo until you have all 3 goals. Hold no for at least 1 second to return to the initial sequence. This will erase your progress and take you back to the starting position. All right, so let me take a look at the chat. Okay. So if you guys have any ideas for a flavor text for this module, then let us know in the chat. We are all ears. Until then, here is the GitHub repository that Quinn has created for this. As you can see here, I've already cloned it into a folder, and now I'm going to open Unity, which maybe I should have done before the start of the stream, but we are all patient people here, aren't we? And we are going to open this Git repository, which I am told by Quinn is literally just a copy of Color Flash or some kind of skeleton prefab for Color Flash remakes. We'll see about this. Now, Quinn, should I hard code the diagram in my first version, or should I actually start by making an algorithm that will generate a grid so that we can rule seed it?
That's a good question.
I think I'm going to hard code it first, and I'm gonna put the bells and whistles on later.
Sounds good.
Okay. So while Unity is still loading, allow me to open Hexamaze, because there is a piece of code in here. Well, I say piece of code. What I mean is, why am I not seeing it? It should be. Okay, so what I'm looking for is a series of Oh, that's right. It's because hexamaze is now fully rule seeded, isn't it? I actually changed the maze even for rule seed 1. Whoa. Debug ASCII maze. I must have... Oh, I see this outputs the hexamaze in an ASCII kind of fashion with... Or does it? I am so confused right now. So hang on, this does use debug.log format. So this means that hexamaze currently outputs an ASCII version of the maze every time it's run. I totally forgotten that I had that in there. But anyway, so what I really want from hexamaze is the hex class. And this is a struct that I wrote originally for hexamaze and which I've since reused for things that use hexagonal grids, such as, for example, zoo. And I'm going to reuse it again. So I'm just going to copy and paste the path, close Visual Studio, and then open the Decolour Flash script. And while that is loading, let me also open... okay, it's not letting me open the scene because this dialog is modal. So what have we? I was telling Quinn it should be what it is now, but with the words in a different order. Oh, you got that idea from Blan. I remember you mentioning that, but you didn't say you got it from Blan. I'll upload it to unfinished. Oh, yeah, that's a good idea. Put it in the unfinished folder.
Yeah, I'm doing that now.
Very good, very good. Okay, so in Decolour Flash, I'm now going to go here and I'm going to say add existing item, and I'm going to paste the path for the hex.cs file, and that will create a copy of the file and put it here. I'm going to change the namespace to Decolour Flash. And then we're going to go to Decolour Flash script, and I'm going to say using Decolour Flash, because I'm probably going to need it. Okay, so coroutine press animations. That sounds like one of the other Color Flash remakes, so I probably don't need this.
That's for the press animation.
So let's start by creating a little enum file called stage. You know what? No, it's actually probably easier with an integer. I'm gonna make it an integer. So we're gonna have an integer stage, and this is 0 means that it is showing the goals, and then 1, 2, 3 is when the player is chasing the goals. So this is a normal operation, right? And then I suppose I will set it to 4 when the module is solved, and that will be how Souvenir will know that the module is solved, is when stage equals 4. Does that make sense?
Okay.
So for each button, I see. I see how it works. Okay. So I will be either 0 or 1 depending on whether it's the yes or the no button, right? I'm going to change this because honestly, sometimes people are a bit, I don't know, people seem to have a desire to put everything in arrays. We don't need this to be an array, right? We can just have a yes button and a no button. And then here I'm going to say yes button dot on interact plus equal yes button press. And then on interact. Actually, the yes button doesn't need to be long pressed, does it? So I'm just gonna do no button press and then no button release. There we go.
I should probably point out that there's code in here which says the animations for pressing the button. Like the button pushes in and pops back out.
Thank you for pointing that out. Yes, oh, indeed.
So you've deleted the coroutine array, but that needs to be there for those animations.
The coroutine array doesn't need to be there.
Okay.
But you are correct that I will need to start the coroutine, and I see what you're saying. So it stops the coroutine when you start a new coroutine, so that you don't have 2 coroutines running at the same time. Okay, fine. I will put this back. Public coroutine array press animations, and that is not public. That is private, and I'm gonna put that here. I'm actually gonna put that here.
Needs to also be a new coroutine array of size 2.
Correct. And that means I can make it read-only because it will never change. I mean, the field will never change. It will always be the same array reference. We change the contents of the array, but not the contents of the field, which just points to the array.
Yep.
Okay.
One last thing, you will need a yes button on interact ended, but that will only be for the animation.
Thank you. Okay.
All right, that's it. Rest is up to you.
Yeah, I guess maybe I should not have. Yeah,
That's okay.
Yeah, I am now going to undo all of that. That was actually not very clever, was it? I didn't think it through. And now we have this problem again, which I seem to have a lot. This is a bug in Git. So I'm just going to go here and add a Decolour Flash to this list. And then refresh this. So, can I please, hello? Thank you. Yeah, so I'm going to... Okay, that can stay, but I'm going to undo this. Yeah, I'm going to undo that and that. Okay, so that was a whole waste of time. But let's see. Oh, module solved also exists. I'm going to say if stage is greater than 3, return false. Because that is how I decided to represent a solved module now. Okay, so I want the action to happen in the button release thing, I guess. So here I'm going to say if I equals 0. Is 0 the yes or the no button? I don't actually know that.
Actually, I suspect I haven't assigned them in the inspector. So
they are not assigned.
Okay, it's just yes and no in that order.
Why are there 4 objects in this array?
That is a fantastic question. There should only be 2.
That's right. So I'm going to change that to a 2, and I'm going to change that to a 2, and then oop. Why is the highlight not inside of the button?
Because if you press the button, then the highlight will sink down underneath the module.
That is a very good point. Yes, we've learned something new again. Okay, now it is complaining about a namespace here. Okay, let's reload that and then open hex thing. Okay, it's the ut.newArray thing. So I'm gonna go to hexamaze and find where that is declared, and okay, so we have a ut file here. So I'm just gonna copy the path to that file and do the same thing that I did with a hex, which is to do this. So Visual Studio will now add a copy of that file here. I'm going to copy the namespace and change the namespace here. And I'm going to delete everything here that deals with the hexamaze markings, which obviously we don't need in the Decolour Flash variant of this. Okay, so all of these are generic functions that we may or may not need. We'll find out. So let's go back to Decolour Flash script, which is right here. All right, so let's do something interesting now. If I equals 0, then yes button press, else no button press. Okay, generate that method, generate that method. There we go. So I think I want the yes button on top. So first of all, if stage is equal to 0, because here it says it says press either button. There you go, press either button. So if stage is equal to 0, then the yes and the no button are the same. So I'm just gonna say this, press the no button if stage is 0. And then here, if stage is 0, in fact, I think I'm gonna do a switch on stage. So if stage is 0, you know what, we don't even need this, because I can just say case 4 return. So module already solved. There you go. Now 0 means that we are currently showing the goal hexes. So when we press the button here, then we're literally just gonna add 1 to the stage, right? That's it. We're just gonna go to stage 1. So in all other cases, we need to verify that the hex currently displayed is the current next goal. Right, so warning to do. Okay, I don't really need the warning because this is currently a compiler error, but right, anyway. So we need the goals in an array. I suppose I can make that a 3-hex array and mark it read-only, like this. So let's make a list of all of the hexes. So I'm gonna do list of hex. Now I think I had a bingo. There we go. It's called large hexagon. I give it a side length, and it gives me all of the hexes that are within that. So here the side length is 4, and then that will give me an array of all the hexes that make up this diagram. So I'm just gonna say this is equal to hex.large hexagon of side length 4.toList. Now I'm going to remove the hex that is at the center because we don't want that to be any of the goals. So I'm going to remove hex 0, 0, and that is the center. And then for I equals 0 to 3, we are going to generate a random index. So we want a number from 0 to hexes.count. And then we're going to do two things. First of all, we're going to put the hexes at that index into the goals array. Which means, oh, I see, goals of I equals that. There we go. This is what I wanted. And then we're going to remove it from that hexes array, hexes list rather. So this will guarantee that we will have 3 different hexes, right? They will not be copies of the same hex.
I should probably point out this doesn't quite yet account for the center hex, but I guess you'll get to that later.
Not sure what you mean. I do remove the center hex right here from the list, so it won't be.
Ah, okay.
Yeah, I did say that. Okay.
Notice. Sorry.
So we've now decided on our goals. I now want to create the coroutine that actually flashes the. Why is the coroutine that flashes the colors not here? I guess I have to write my own. Let's see. We have the screen text thing, so I assume I'm gonna just write to text mesh to screen text.color and screen text.text, right?
Okay.
So private color array. In fact, how about a private static read-only color array? So what are the colors? The colors are blue, green, cyan. Actually, cyan doesn't exist. Right. Nope. So red, magenta, yellow, and white. Is that correct?
Yes.
Perfect. And then we're gonna do a string array and call it color names. And then I'm going to replace all occurrences of color dot, actually comma space color dot. I'm gonna replace them with this. Bang. And then replace the one at the start manually and the one at the end. And there we go. These are our color names. So I am now going to start a coroutine to flash the colors. There you go. Create that method. And while stage is less than 4, which means while the module is not solved. We are going to be waiting how long between flashes?
Let me check the other modules. I think it is 0.75, but let me check.
I would have guessed 1 second, but I'm gonna go with 7.5 until you've figured it out. So,
Yes, that is 0.75.
Okay. So if stage is equal to 0, then we need to show which of the 3 goals, depending on... Okay, so I can use time.time to just get a float whose integer portion changes once every second. So if I multiply this by 0.75, I think I need to divide it by 0.275, don't I? Yes. And then it will change. No, hang on. Is it multiply or divide? Yeah, it's divide. So that when you reach 0.75, it will already become 1. Okay, so I'm going to integerify that, and that will tell me which color I need to display. So display show color, let's call it that. So I want the word and the color, right? So I just realized, so I have the hexes in the goals, but I don't yet know what the actual colors and words on it are. So for now, I'm going to comment this out, and I'm going to, so I'm going to make this a static read-only dictionary from hex to, I'm going to call it color info, or should I call it hex info? Doesn't really matter. I will create this type, and I'm going to call this hexes, and this will be system collection generics, and then generate this type, color info, and this will be a struct containing the actual color and the word, I guess. There you go. So this should not say class, this should just say struct. And now we need to actually populate this with all of the info that you have right here in the manual. Okay, so I need to remind myself how the hex system works. I know that there are two coordinates, Q and R, and I know that R is vertical. So this is 0, 0, this is 0, 1, this is 0, 2. I suspect that this is 1, 0. In other words, Q goes southeast. I'm not completely sure of that. What is the easiest way to figure that out? I suspect that there isn't a way to figure that out because if it goes up here, then you literally end up with the same diagram just vertically flipped. So I'm just gonna go with this and just see if it works. All right, if we run into bugs, we'll get to them. So that means that the top left corner, the Q coordinate is -3, and the R coordinate would be 0. All right, so at -3, 0, our color info, I would like to create a constructor. Is there a, there we go, do this, yes, perfect. Ah, oh, I didn't even know that Visual Studio had this feature. Cool. So I can create this color info by just passing a color and a word. So up here, we want the color to be red and the word to be green, like this. Okay, now I'm going to, I think I have a suspicion that I probably want this to be an enum, so that I don't have to write out the string each time. What do you think?
Yeah.
Okay, I'm going to make it an enum. Let's call it CF color for Color Flash. Oh, I misspelled that. Color. Make that an enum. Make the namespace Decolour Flash. And get rid of all the usings. Alright, and then we're gonna do this. Let's do this, change all of these to new line, make all of these capitalized, put a comma at the end of each line, and then paste that here. Okay, so these are our 6 colors. And then in color info, instead of string word, I'm going to say CF color. There you go, that goes there. Okay, what went wrong there? CF color. Okay, now it worked. Did you? I don't know if you noticed that. It said using lowercase d, semicolon. That seems a weird bug. Okay, so now, instead of green, I'm going to say CF color.green. And now I can be certain that the compiler will let me know if I misspell one of those colors. You know, so if I accidentally type like, you know, gren or something, if it's a string, then I wouldn't notice until, you know, someone runs into it. But now I will notice. Okay, So now I'm going to, let's see. So horizontally, I should have started here, because then I can just increase the R coordinate before moving on to the next row. So I'm going to do that. I'm going to start with 0, -3, and I'm going to write this in columns and later use regular expressions to fix this. So we have 4 hexes up here, and the words are blue, green, red, blue. And the colors, which I should write first because they come first in the constructor call, are red, green, white, magenta. All right? Then in the next row, we have -1, -2. Okay, and this one goes from -1 to, let's see, 0, 1, 2, 0, 1, 0, 1, 2, 3, right? It goes all the way up to 3. Okay, so the
Colors first.
hang on, this is wrong. What did I write here?
You wrote the colors, then the words.
Yeah, okay, wow, I'm confusing myself big time here. Okay, so we want the colors first. So it's yellow, magenta, blue, red, green. And then the words are R, W, Y, W, M. And then we move on to -2, -1. All right, and that one goes all the way. Come on, let's do this. 0, 1, 2, 3, 4. Let's see, 0. No, this is 0, 1, 2, 3. It only goes up to 3. I should have known that. Because it'll always be at most 3. Okay, so the background colors are blue, green, yellow, white, magenta, blue. And the letters are M, Yankee Golf, Bravo, Romeo, Golf. And then the next row, we have -3, -2, -1, and then no 0, 1, 2, 3, 0. The background colors are red, white, blue, red, green, red. And by the way, for those of you who haven't noticed this yet, on this diagram, apart from the center cell, there are exactly 35 cells, and Quinn has managed here to 36. What did I say?
35.
It's 36, which is exactly 6 by 6, which is the number of combinations that the colors can have. And Quinn has managed to make it so that no two colors, like, you never have the same color next to one another. So, for example, you never have a red background next to a red background, and you never have a Romeo next to a Romeo. And all 36 combinations are exactly represented. Now, this one should only go up to 2. -3, 1 is here. So the backgrounds are yellow, magenta, green, white, yellow, magenta. And the letters are not that. Okay, there we go. And then in the next row, we start at -3, 2, right? And then that goes up to 1 only. So 2, 1, 0, 1. Delete that and delete those. So the backgrounds are white, blue, magenta, yellow, red. And the letters are these. And finally, we are going negative.
You said white, blue, magenta, yellow, red. Where are you getting
Did I mess up? Which one's wrong?
No, you just said the wrong thing out loud, I think.
Oh, okay. I do that sometimes. So here, the Q coordinate, the R coordinate. Oh, wait. No, that's right. The R coordinate is 3. This is correct, I think. Yeah, it is correct. So Q is southeast and R is south. Okay. I constantly need to unconfuse myself because I just don't do hexagonal grids often enough to be genuinely used to them. Okay. So now we're gonna change all of this. First of all, at the start of every row, we want new hex open parenthesis like this. And then, let's see, I'm just going to do this. Tab, 1, 2, 3. We have 3 tabs. So we're going to do this, and then comma, and then the second one, close parenthesis, comma, and then new color info, open parenthesis. And then we want, I haven't thought this one through. Let's just put them in like this. This would be CF color. Actually, I'm gonna go color dot and then CF color dot $4. That should be fine. And then close curly comma. Okay, that seems good. And now we're gonna change all R's to red. And yes, I know that the ones after color dot need to be lowercase. I will fix that in a sec. So for now, let's do this. Green, blue, white, magenta, and yellow. Okay, and now I'm actually just going to select this whole column and just lowercase that. And now I can copy and paste that here. And now we have our dictionary. That represents the diagram in the manual, if I haven't made any mistakes. Whew. So far, so good. Now, okay, so we're gonna use this modulo 3 to determine which thing to show, and the thing that we show is goals of that, which gives us a hex, and then we're gonna look that up in our diagram, and that will give us a color info. So we're gonna pass the color info into the show color method. And then we're going to say text. No, it was called, what was it called?
Display screen text.
That's right, screen text. So screen text.text is going to be colorinfo.name, which is actually called word, which we're going to toString and then toUpper invariant. And then the screen text color is going to be colorinfo.color. So this obviously is a color, so that works. And this one here is a CF color, which I can toString to turn it into the, into a string representing this. But then I want to upper invariant that because that's how this module displays things. All right. So I think I'm going to change this so that it's not even a coroutine, because it doesn't need to be a coroutine. It's going to be always active, except when the module is solved. So I'm just going to do it in an update method. Now, why is that complaining? The body, okay, because I have a yield return here. So I'm going to say if that is greater than 3, then return. Then we're going to do this.
Probably points out, does your method count for stage 1 where there's a blank display?
Very good point. You are absolutely right. In stage 0, we want there to be a blank display between repeats of the sequence. So I'm going to make this modulo 4, but at that point, let's see, we need that. But then I'm going to say, if that index is equal to 3, then we're going to need to blacken it out. So I'm going to pass null, otherwise goals of index. Then I need to make this nullable. I need to tell this that it's a nullable color info. And then here I'm going to say if color info equals null, then the text needs to be empty, otherwise that. And then here, if color info is null, then we don't really care about the color if the text is empty. So I'm just going to say if color info is not equal to null, then color equals that. Okay?
All right.
I think this is fine. Okay, so now we have a showColor method that can take either a color info or null, and if it's null, it will show a blank screen. Okay, so this is if stage is equal to 0. In all other cases, stage is either 1, 2, or 3, in which case we need to flash the current position. So I'm going to put warning here, flash current position. But for now, I'm going to just see if this works. Control cannot fall. Oh, yeah, that's right. So here I'm going to put a break. So we should, it should work to show just the 3 goals, right? It should be showing us the 3 goals. So let's run the module. and see what happens. Now, before I run it, I want to set this display so that it shows me the module. And then we run it, and we have this. Okay, it shows white on white, green on green, and yellow in green. Now let's... Okay, so here's an annoyance I have. If anyone knows how to prevent this from closing all my tabs, I would be very grateful, because it's really annoying that it does that. Okay. So I just realized we don't need either of these anymore, because we have the color info. Well, I'm gonna keep it because I might still want to use this in the
Logging.
in the rule seed generator. Except that this one here is going to be a CF color array, and I can just do this. Oh, it already knows. The autocompletion gave me exactly what I needed. So I can use enum.getValues to get an array containing all of the values that this enum contains, which is these 6. And then that's, yeah, there you go. That's what I need here. Okay. Now, where was I? Oh, yes, that's right. I want to log the goals. So I'm going to say debug.log format, goal. Okay, so first of all, Decolour Flash, obviously. So goal number 1, 2, or 3 is at that. So the module ID, then we need the goal number, which is i+1, and then I'm going to say goals of i.q and goals of i.r. So these are the coordinates of the hex as I described. And okay, so 0 minus 2, it claims, is white on magenta. 0 minus 2 is indeed white on magenta. Perfect. Negative 3, 3, that would be this one here. That should be white on blue. And it is. And then we have green on magenta. No, it was magenta on green. So it would be this one. So we expect this to be 3, negative 2. And indeed it is 3, negative 2. Perfect. So that worked. And I put in the coordinates correctly. Okay. Now if I press yes, it will crash because... Oh, it doesn't actually... Okay, it doesn't crash, but it stops showing us anything because the update method doesn't do anything when stage is equal to 1. Okay. I think I'm going to remove this line because we no longer care when you press down the button, we care when you release it. And here, I'm just going to say... no, not here. Here, I'm going to say... do I even need to log when the user switches from stage 0 to stage 1? Probably not, right?
No.
Let's not. Okay. Now comes an interesting question. We need to generate a random triangle.
Real quick, Goofy is in the chat now. So hello, Goofy. And he says,
Welcome.
reel it all close. Okay, we can read it.
Okay, let me read the whole thing. A lot of the Flash module's flavor text are quotes of some sort. So we could do that. Colors first, word second is definitely interesting. Okay, that's an impressive. Regex? Regex? I don't remember using any... Oh, I used a regex in Notepad. That's why. That's right. That's strange. I never had this problem before. That reload all closes all tabs should be fixed in 17.2.3. Let's see what version I have. It's 17.3.0. I'm sorry, I have a newer version than you thought. But hey, welcome, Goofy, and I hope you will enjoy this stream. After the stream, I will Google for whether there is an option to stop it from closing all the tabs.
When that happens, do you select reload all? What option do you select? Okay.
I suppose I could try pressing reload instead of reload all, but I suspect that it does the same thing. Anyway, so we now need to find a way to create a random triangle. Now, I've already thought a little bit about this. And here's the thing. There are actually fundamentally only 2 different types of triangles, right? You always have 2 hexes on top of one another. And then the third one is either to the left or to the right of that, right? An equivalent way of thinking about a triangle is to think about the intersection points, right? Every intersection point within the diagram is exactly like a triangle. Does that make sense?
Yeah.
Okay. So what I could do in theory is I could pretend that there is another hexagonal grid laid on top of this, which is shifted. Wait, is that even? Oh, no, that's not even a hexagonal grid because this would. Okay, wow, I'm confusing myself again. So, which way would be better to represent it? Should we try to go with the vertex or should we? I think the easiest way would be to have just the top one and then a Boolean saying whether the left one and the left or the right.
Okay. Also, should probably account for whether the hex is at the bottom of the grid, so there is no bottom. But I suppose you know that.
Yes. Okay, another possibility, I'm thinking it might actually be easier in programming terms to just have a list of 3 hexes and to just make sure that, I think that's what I'm going to do. I'm just going to make it a list of 3 hexes. I was trying to be too clever by making the representation compact, but in doing so, I would have made the code less readable and less understandable. It's much, much easier to just know what the 3 hexes are, right?
Hmm.
And
You have
then
to know what they are anyway. So when you do
yeah, exactly. And when the user presses the button to do the triangle flipping, you can just remove the current hex from that list and put the other one in. So let's do that. Okay. So I'm going to have these are all static here. Private hex. Should I make it a list or an array? I mean, it's always going to have 3 elements, but it's going to be easier in terms of the handling, to remove things from a list and add things to a list. So I think I'm going to make it a list. Current position. I also need to remember what the start position was, because when the user resets the module, I want to set the current position back to the start position. Now I'm going to set both of these to read-only because I'm never going to change the contents. I'm never going to switch to a different list. I'm only changing the contents. And then here we're going to decide on a start position. Now the start position consists of 3 hexes. The first hex can be any hex at all except for the center. The second can be any hex that is a neighbor of the first. And then the third one needs to be any hex that is a neighbor of both of those. Right? Now, ideally, I will also make it so that none of those 3 are goal positions. So I'm actually going to reuse my hexes list that I've already created here, from which we've already removed the hexes that are the current goals. And I'm going to construct the starting position by saying starting position dot add. Okay, so I need an index again, so I'm just going to put that here so I can reuse the variable. So index equals that. And then we add hexes of index and hexes dot remove at index. So that is the first thing. So we've just selected any random hex. Now I'm worried because what if the goal thing, hypothetically, let's say the goal thing chose this hex and this hex to be a goal, and then our starting position thing starts by choosing this, and then it doesn't find a third one that, that could be adjacent. Maybe I should just make that a try again loop. Right?
Alternatively, what you can do is you can just find any hexagon that isn't a neighbor of any of the goals. Actually, that might not be possible.
No, why would that not be possible? I think that's very clever.
Okay.
Okay, so in the situation that I described, where this and this is the
hex, yeah, and then I'm gonna claim hex number 1 should never be that yellow.
Exactly. So
Because it's
let
adjacent
me
to a
let
goal.
me think this through. So if these are the first two goals, then if we exclude all of their neighbors, then none of these and none of these can be selected as part of the starting position, or at least not as the first of the three hexes in the starting position. I think that is fine. So what is the most number of hexes that we can exclude this way, right? This would exclude 7, and this would exclude another 7, this would exclude another 7. So that would be 28. 21. 3 times 7 is 21. Which means that we still have 15 left. As way enough. So I think your strategy is very clever and probably works very, very well. So
real quick, Blanana's posted in chat where the hexagonal coordinates I've explained. Yes, they were. I suppose you can quickly recap.
Yeah, so the idea here, so imagine it's kind of like X and Y, except they're called Q and R, and Q goes towards the southeast. And also 0, 0 is the center square. So this one here would be 0, negative 1, this is 0, 1, this is 1, 0, and this is 1, 1. And similarly, this is negative 1, 0, this is negative 1, negative 1. Okay? I hope that is clear. Okay. So instead of rnd.range, I want hexes.where. So I want to find a hex where none of the goals are neighbors. So contains H. And then pick one at random. Okay, so this is complaining because this is an integer. Whereas I'm making it, okay, so I'm going to move this back in here, do that, use var, and then I'm going to say var random hex, let's call it that. So this will pick a random hex, and then we add this random hex here, then we're gonna use remove to remove it from here. Okay, and then we want a random neighbor of that hex. So random hex 2 equals hexes where random hex.neighbors contains H. Pick random. And then we add that and remove that. And then we want a third hex, which is neighbors of random hex and also neighbor of random hex 2. Okay, and then add that. And let's also remove that. Actually, we don't really need to remove that because we're done here. So the question is, can this ever get into a situation where it cannot find? So even if, hypothetically, if this were one of the goal positions, right, it would erase this and this from being considered for the first hex, so it might choose this one, but then after that, it is free to choose this and this, or this and this for the starting position, and it will never get to the goal position because it only goes one step away. So, wow, your idea was extremely clever. It will guarantee that the start position will never contain a goal position. And it will also never get stuck in an impossibility. I'm very impressed. You probably didn't think of that, but it worked out very well. Yeah. Okay,
actually,
so we have
also
Go on.
I think also with my logic, like you'll never have to actually check if any of those neighboring hexes are goals, because you already know that because all the
Right. Okay. So now we have our start position and our current position. Now, if the stage, so if we're here, we want to flash the current position. So now the index is going to be time.time divided by 0.7. Did you check that it's 0.75?
Yes, I did.
Okay. So this time we want to go modulo 3 because there is no gap between repeats of the sequence this time. And we have this thing again, so I'm just gonna make that outside. Actually, wait, I can do an else. There you go. Not that it matters. So we want to show the color of the current position at index. There you go. And then I can actually literally just put that right in there. Okay, so that current position gives me a hex, so I need to look that up in hexes to get the color info. So there we go. And then I don't need the else after all. Okay. Right, I think that should work. Okay, I want to output. Start position is, let's just do this. 1. And we're gonna say start position dot select. So each of these will be a hex, and then I'm gonna go string dot format on this, and it's gonna be 0. Hang on, actually, does the hex type have a toString method? And it turns out it does, and it does exactly what I was about to write. So I don't actually need to do this. I can just do startPos.join with commas. There we go. And that means that this, I can just say goals of I. Okay, build succeeded. And there we go. So the start position is, let's see if we can find it here, -1, 3, that would be this one. And then -2, 3, that would be this one. And then -1, 2, that's this one. So we expect it to cycle red, yellow, green as words. Let's go. Red, yellow, green. There we go. And the background color is green, white, magenta. Green, white, magenta. That is working so perfectly, it's almost embarrassing. So now comes the interesting part. When you press the no button, we want it to flip to the other. We want to flip the hex that is currently being displayed to the one that is on the opposite side of that triangle. How do we do that? Well, let's see. Button release. Here we go. Yeah, this is where we are. Okay, verify that the hex currently displayed is the current next go. Oh, this is when you press this. This is what should happen when you press yes. Let's see if stage. If stage equals 4, return. Else.
You have start pause there.
I tried to avoid that twice. So here, when you press the no button, we need to find the hex on the other side of the current triangle. Okay, so first of all, the index within the current triangle is this, right? Now, I think I'm going to engage in some good practices here, and I'm going to make a float for the flash speed, which currently is 0.75f. So I want to make it so that I can change the flash speed by just changing one number, and I don't have to change it everywhere. So that's one thing. But the other thing is also that this should really be a method, because it has, it has a semantic meaning to us. It is the index within the current position. So I'm going to call this, I'm going to extract method, and I'm going to call this get index, let's just call it get current index. And then let's write a comment here, returns the index within current position, current pos, which is currently flashing. Right. And now I can safely reuse that method here. And know that there won't be a discrepancy between this and what is flashing, right? They will always calculate the same value because it's the same method. Okay, so we want to find the hex on the other side. So first, we're going to find what the... let's... Okay, so the current hex that we're on is current position of current index. All right, so let's remove that from this list, and then we're gonna add, actually maybe we shouldn't remove it yet because we need to stay in place if we're gonna hand out a strike. Actually no, we can just put it back in the list, can't we? Yeah, let's do that. So the opposite hexes are, let's see, hex dot large hexagon of 4, where that hexagon's neighbors contains it contains everything from current pos, right? So current pos all, current position contains that dot to array. Okay, so this should give us 2 hexes normally, but sometimes only 1. Now there's 2 things we want to exclude. First of all, we want to exclude current hex. So now it will give us at most 1. But the other one is we also want to make sure that it's not the 0, hex. Okay. Now, if opposite.length is equal to 0, then we need to hand out a strike, because you've either hit the center hex or, you know what, I'm actually going to do this so that I can distinguish those 2 cases. So if this is equal to 0, then we have hit the edge of the board. And if the length is equal to 1 and it contains the 0, hex, then we've hit the center square. So, let's see. I just realized something.
Yeah.
Let's say you're in stage 1. You're looking for the first goal.
Yeah.
Then you press the yes button. So stage now becomes 2, and you're looking for the second goal. Right? And then it goes to stage 3 and you're looking for the third goal. You press yes. The stage number now increases to 4, but you're still not done because you still need to get to the center. So it is actually stage number 5 that needs to... okay, so now I need to be a bit more careful because I need to find all of the places where I have used that number. So, this should be fine. This is fine.
Update is wrong. If update stage is greater than 4, it should be... Oh, no, that's correct.
Yeah, I changed it from greater 3 to greater 4.
Okay.
Right, 1,
also,
2,
in line 142.
3, 4. Sorry, say again? Oh, yeah,
Line
here.
142.
Yep. Very good, very good. Okay, same here. That is now stage... Wait. No, that's correct, right? I already changed that. Ah, there we go. This needs to be a 5. Wait, does it? Yes. Gosh, I'm so unsure now. Okay, stage 5 is when we're done. Alright. Okay, so if opposite.length equals 0, we are now going to output a log message to tell us that we've hit the edge. You attempted to go over the edge of the diagram. Strike. Module.handle strike. Okay, conk. Else, if opposite length equals 1 and opposite 0.q equals 0, .q, thank you, and opposite 0.r equals 0, then you attempted to hit the center of the diagram before you are done. Now that's only the case if stage is less than 4. Because if we're in stage 4, then we're good, right? If we're in stage 4, then we actually solved the module. So we need to handle pass. In all other cases...
You need to set stage equal to 5 here as well.
Oh, very good. Thank you. Or just stage ++, I guess. Haha. So in all other cases, we want... Oh, also after a strike, we want to reinsert the current hex into at position current index. This will restore the list to its former glory. Okay, in all other cases, we want to we want to add the new hex, which is opposite 0. Okay. I think this should be good. Now the only thing that is missing is that when you press yes correctly, we need to... Let's quickly do that as well. So if current position at the current index is equal to goals at stage -1, then we have successfully achieved goal number. Let's just do that. So that should be it, right? If stage is equal to 1, then we have now achieved goal 1, and then we're just going to go stage ++.
Should probably add in the manual. I don't think there's a clarification saying that you have to collect the goals in order, unless I've missed it. Oh, no, there is. Sorry, ignore me. You're good.
Yeah, okay. So in all other cases, we pressed yes on which is not the current goal. Right? Let's say, but the current goal is that strike. Okay, so we press yes on the current, so that would be current position, add get current index. That. But the current goal is goals of stage -1. There you go. And then module.handle strike, and nothing else changes. All right, let's see if that works.
All right, I suppose I can expert for this.
Well, actually, before we do that, do you mind if I just quickly spend some time to make this highlightable?
Sure.
All right, so let's open. Oh, it's already open. I guess I can close this once Notepad++ responds. Thank you.
Use the HTML in the unfinished. I pushed it to the repo.
All right, let's do that. Unfinished. Decolour Flash. Save here. Decolour. Oops, I misspelled color. Yes, replace that.
Did you really?
Yes, chap. Okay, so let's see what happened here. Let's do this. Okay, so we have all of these G tags which have a path. Transform rotate 0. That can probably very safely be removed. Why is the stroke width in centimeters? Why is there a color attribute? We most definitely don't need that. Also, class equals center is not defined in the CSS. Okay, the rest looks fine. So I'm going to do this. I'm going to say stroke equals black, stroke width equals 0.01 centimeters. So this will just make this smaller. All right, and then I will copy this, and then I probably don't need that to be another separate group, so I'm just gonna do this. And now instead of this fill equals thing, we want class equals highlightable, fill equals transparent, and then we want all of those text objects gone. Right. And since these are now individual objects, we don't need to wrap them in a G tag. Instead, we can just move these transform tags into the path tag. So the it's a bit annoying right now that, okay, I'm going to fix this. I'm going to change all greater than signs to tab greater than tab in the selection. And then I can easily just select all of this, copy, and then undo, and then paste it all here. And then get rid of these G tags, boink. And then I guess I can also get rid of these tabs. But actually, you know, having those tabs isn't bad because it makes it all nicely aligned. So I think I'm going to just keep the tabs. How about that? Let's refresh this. Nope, let's refresh this. Okay, so something went wrong. Yes, and I know what went wrong. The So this stroke black and stroke width thing should not apply to the text object. So removing it from these objects here was a mistake. So I'm going to put that back, refresh, and now I can highlight these. I'm going to use, I'm going to use the black highlighter that is a bit more visible. Okay. And now we get on with this. Okay, so we have blue and white, which is this one here. Okay, I'm going to use colors for these. Actually, it's gonna be hard, isn't it?
You cannot use orange or cyan, so it doesn't. So it like.
Yeah, but the orange and the cyan will blend into the color of the hex.
Oh,
so
enough.
You know what? I'm gonna use black, and I'm just gonna try and remember the order. So the next one is magenta in blue, and then magenta in white. So that would be this one, and then this one. Okay, so we're going in that kind of order. This, then this, then this. That shouldn't be hard to remember. Okay, and now I'm gonna press any button. I got a strike already. I thought I was in stage 0. Let's see, when I press the yes button, oh, I see.
You don't return.
Perfect. Okay, so close that and start over. Okay. So we have magenta in green, which is here, and then we have yellow in blue and magenta in magenta. This one. Okay, so it's this sort of up-pointing chevron. So we start here and then go here. Okay, now let's press any button. And suddenly we're in, let's see, magenta in red. That is here. Blue in green and yellow. Okay, so this is our triangle. So I'm going to press on the yellow in magenta. Okay, and now we have the magenta in red, the green in blue, and the blue and green. That worked. And now I need to press it on the magenta in red. And now I should be here, and then I'm gonna press it blue on green. That one. And now I should find the magenta in green. Yep, there it is. And it says achieved goal number 1. Nice. So next I'm going to press the green and blue, that one, which means I'm now here. Then I'm gonna press the magenta in green, that's here. And then the red and magenta, that one. So now I should find the yellow in blue. And achieved goal number 2, perfect. Now we press the white on red. And then we press the... I'm gonna test that this gives me a strike if I press yellow in blue. I missed it. There it is. You attempted to hit the center of the diagram before you are done. Strike. Okay, so we're going to press the blue and white, which is this one. And then we're gonna press the yellow and blue.
Extension.
Oh. Index out of range. Oops. And that happened both times. Okay, so let's see.
You didn't move from the initial.
We have blue in white, yellow in blue.
Yeah, your position didn't move either time.
Yeah. Okay. So, why would that happen? Let's think. It's in line 222. Current position dot add opposite 0. Okay, this is why. But still, it should have worked the second time. Okay, so what I should have done really is to put an else here, right? Yeah. I mean, after this, the current pos list will be, borked. It will have only 2 elements in it, but that won't matter because one stage is equal to 5. Oh, sorry. What am I talking about? Yeah, no, the hand. Oh, I see. This is where we check that. Yes, okay. maybe I should make it like this. If stage is equal to 4, then we do this, else we do this. This might be a little bit more readable, because this is the full condition for solving the module. And then this just says in every other case where we hit the center. Okay, so let's try this again.
Also, what you can do in the meantime is test trying to go outside the grid.
Yep, I could try that too. Red and yellow. So here, this is our first goal. And then we have red and white and green and magenta. Red and white and green and magenta. So it's like that and then that. Okay. Let's see. Pardon? Yes, exactly. White and red. So we are here. Is this marked? Yes, it is. White and... I'm so confused. White and red, blue and white, red and magenta. Blue and white and red and magenta. Okay, so we press the red and magenta. And we should now be here. And then we press the blue and white. That one. And we should now be able to find the red and white. And there it was. And here it is. Okay, achieved goal 1. And I get a strike. Okay. This is so I have correctly tested that you get a strike if you do them out of order, because this one here is supposed to be the first one. Okay. So we now press white on red. No, hang on. We are actually up here, aren't we? Yeah, we are here. Okay, so I'm going to press the white on red still, though. Okay, so we're now here. Then I press the red on white.
Press the yellow on blue.
Oh, I see. Yeah, you wanted me to test the... Yeah, okay. I'll do that now. So yellow and blue. So I should now be here. And now if I press the white on magenta... Oops. You attempted to go over the edge of the diagram. I should have pressed the green on green, obviously. Okay, and now we go red on yellow. Okay. So I've achieved the goal, and I've also flipped back over here. So now blue and red. There we go. And then we want white and magenta. Thank you. And then yes on red and white. Bingo. Okay, and now we press the green on green. Red on white. Yellow on blue. White on red, blue on white, red on magenta, blue on green. Whoop. I don't know what I pressed. Okay, blue and green is still there. Red on magenta. I must have pressed that one, so I went back. So I'll press the red on magenta again, and then I should be here again. Whoops. So blue on green, let's go. That one. We are now here, and then yellow on red. There we go. And then white on yellow. And then we're looking for green on magenta. This one. And then we're gonna press the blue on blue, which puts us here, and now pressing the green on magenta should solve it. Bang. It should go blank, right?
Yeah.
It should go blank. Okay. Update. There you go. Done.
Well, do you want that to happen every frame? I don't think you want that to happen. I think you could just call.
I don't think it matters.
Okay.
In fact, I think I'm gonna do this. If stage equals 5. There you go. Yeah. Right. I think we're good, right?
All right.
So have we just made a complete and full and utter and perfect module? Like,
No,
No?
you haven't implemented the reset function yet.
Very good. Thank you. The reset function. Okay. So,
One moment, I need to use the bathroom. Give me 2 minutes.
well, I'm still going to be programming C in a bit, I guess.
I'll be back.
Private float held time. So, let's see. When we press down the button, the no button that is, yeah. Here. If I is equal to 1, then held time equals time.time. So this is obviously redundant. Well, we do need to return false. All right, button release. So if we release the no button during a stage other than 0 or 5, let's see. If time.time minus held time is greater than 1 second, if we've held this for greater than 1 second,
I've returned
then reset. Welcome back. So we want to erase the current position and then put the start position back in and set stage. Nope. Stage. God damn it, I cannot type anymore. Stage equals 0 and then break.
Real quick, I don't think the start position actually needs to be consistent. Up to you, though.
Well, it doesn't need to be, but right now this is the easiest in terms of programming, right?
Fair enough.
So are you suggesting that, I mean, hypothetically, like imagine you have your sequence of goals, right? And then you press the button and then you find that your start position is like on the opposite side of the grid. Do you want it to be a possible strategy that you reset the module in the hopes of...
Okay. All right. That's convinced me.
All right. All right. Do our viewers have anything to say about this? Hello, GM Rubix. Hello, Timwy. I'm here to watch you. You know, I thought you were here to eat a sandwich and ignore me. All right. And yes, Rubix, you're not the only one who is looking forward to Galactic Puzzle Hunt. I'll be there too when it starts, although not on your team, because you are doing TTBNL, aren't you? The text is always at the same X and Y offset. Is there a fancy way to get rid of the extra duplication there?
Manual.
Oh, I see what you mean. Yeah, that's actually a good point. In theory, you could add 1.5 to all of these. No, actually you can't, because that would affect the actual hexagon. But yes, you could remove the x equals 0 because 0 is just the default value. But I don't think it's a problem keeping it there. But to answer your question, no, you cannot set the x and you cannot set a different default value for x and y other than 0. You can only omit it if it's actually supposed to be 0. Is that flavor text identical to Hexamaze? Yes, we haven't thought of a new one yet. So Taz, if you can think of one, a flavor text for this module, then we'd love to hear your input. In the meantime, what was I going to do? I was going to test the reset function. Thank you. Okay, so let's see. I'm just going to press something. So we have green on magenta. That's actually here. And we have yellow on white, that's here. And then we have blue on yellow, that's here. And now let's press no for a long time and then let go. Okay, so it's doing the... Okay, and now I press this and we're back to the same thing. Yep, that is working. All right, cool, cool, cool. Now, I feel that it should make a little tick sound once you've held it for long enough. So I'm actually going to change the strategy here. I'm going to make this a coroutine hold routine. I'm going to call it hold routine. And then when you push it down here, I'm going to say hold routine equals start coroutine hold button, I guess. Generate this method, and then this will yield return wait for 1 second, and then it will play a game sound, which is the button release button. There you go, button release sound rather. And I'm going to okay, so this one.transform, there you go. And when you press the button, I should probably also play the sound when you press it, and then this should be an I.
So add an interaction punch.
Exactly, yes, we need that too. So we're gonna go button cells of I add interaction punch 0.5? Yeah.
Yeah.
Okay. Right, so held time doesn't exist anymore. So after you've held the button,
Procyon's back.
welcome back, Procyon. So I have an idea. So the hold routine, right, it will assign this to this variable, right? When this 1 second thing is over, I can set this to null. And then here in my no button press thing, I can say, if that is not equal to null, well, if it is equal to null, then it's been pressed for long enough. And in all other cases, I need to stop the coroutine. Right? Let's see if that works.
Unfortunately, we're not going to be able to hear the audio sound.
I won't hear it either because the test harness doesn't play the game sounds.
Well, that's what I meant.
Right. Okay, so I'm going to press a button, and apparently that is working. We want magenta in white, blue in blue, and green and magenta, so we're here. I didn't mean to press yes. Let's press it on blue and blue, I guess. So we are now actually here, right? And then okay, so that worked, pressing it less than a second. Now if I press this for long enough, it doesn't seem to have changed. So now if I let go, okay. I don't remember what the initial sequence is, so I don't know if this is correct, but let's see if the start position has correctly reset itself. Blue and blue and green and magenta. Yes, it is back to this. All right. Ladies and gentlemen, the reset function is working. Now all that is left to do is TP support, autosolver, and roll seat support, and souvenir support, and tutorial video.
Yeah.
Okay, do you think I can do rule seat support in 37 minutes?
Probably.
Oof.
Okay, I don't want to stress you out though.
Yeah, it's fine. That's good. That's good. So here is what I am going to do. Let's see. I'm going to do it in the C#. No, actually, I should do it in JavaScript first, so as to because then I can see the results immediately. So I'm gonna see.
39 minutes since it starts too fast the hour.
Okay, these are in an inconvenient order. That is unfortunate. They're actually in reading order. That's a bit annoying.
Well, that can be changed, yeah.
Yeah, well, what's the easiest way to change that?
Shift, Control, and up and down arrows a lot.
Well, I won't be able to see if they... Oh, wait, I can if I do this. Okay, now. Okay, so that and then that. Actually, what I can do is these text objects don't have a fill attribute. So I'm going to say g fill equals red, and then I will see the ones that I haven't moved yet. There you go. Clever, huh? So
yes.
let's see. So I know that this is the red and yellow, and then we want 2 more after that, so this is the next one. Yes. And then I should probably put a new line there. So that is the red, and then the MW, and then we want 3 more after that, those. And this one should be, let's also do that. Yep, that was also correct. All right, then we have the red one, then we have the W here, and then we have the yellow one, which should now be the 4th one. And then we have the next one, which should be 3 more after that, so this one. Yep, and then 4 more after that. This one. No, that was 1 too many. Okay, so it's this one. I should have realized that just looking at the x-coordinate, actually. Okay, so now the next one is this one. Am I doing this in the right order? I'm doing it in the same order as this, so... Yes, I am doing it in the right order. Okay. So the next one is the second one, so this one. You know what, I'm gonna delete that. So the next one is the 3rd one. And then we want 1, 2, 3, 4, 5. This one. And then we want 1, 2, 3, 4, 5, 6, 7. This one. And now I'm just gonna guess, because 50 is very likely, yep, it is that one. Okay, and now, obviously the first, and then the second, and then the second, and then the third, that. Actually, I just realized it's always going to be the first one whose x-coordinate is bigger. See? Yeah, so now I have a system. So that, and then this. No, wrong. This, and then this, and then this, and this. And one more. Must be this. Haha! That was really cool that I thought of that. Okay, then we do this, and then this. And then the rest are obviously in the correct order. Okay. So now that I have them in the right order, I can now do this. I'm just gonna remove all the ends from the end there, remove all the commas, remove all the new hex that. Okay, so I want to turn these into IDs. Right, so I'm going to call it like hex minus, and then the comma into another minus. There we go. And now these are unique identifiers that will identify the hexes, right? And then I can say ID equals that, spaces in front, copy the whole thing, and put it here. Right. I should put tabs after. In fact, I will put tabs like that. Okay, so now they are all nicely aligned. Cool, huh?
And the last one is missing.
Yeah, why is the last one missing? Right,
Oh,
it's because 0, 0 is
0,
missing. So 0, 0 would ordinarily go here. So I'm just going to call this sentry. And then put that there. Okay, cool. Right, and then I can turn these tabs into spaces. Okay, so I have 30 minutes left. Can I do this? Can I really do this? I don't know if I can do this. All right, let's undo all of this. Okay, let's replace this with that so that I can make these JavaScript arrays. Let me take a look at the neighbors function just to see how it works. Oh wait, no, I should use the distance function. Yes, the distance function. So the thing is, I can subtract the Q and the R from 2 hexes, and then do this distance thing, and then that will tell me the distance between 2 hexes. So that is how I will know adjacency. Perfect. Okay. So, script, rule seed. See if that works. Yep, that works. Very good. Script, function set rules rnd. Function set default rules rnd set rules rnd. Okay, so let hexes equals all of these. Let's put commas at the end. There you go. Actually, I probably don't need this to be super long. I can just do this. There you go. So these are our hexes. Okay. Now, let's see. Oh yeah, also I need the color. No, I can just use the numbers from 0 to 35 for the color and name combinations. I'm just gonna, I think I'm just gonna have the actual colors, which are all of these. Let's just do this and sort this, and then make it like this. Oops, there. Oh yeah, that's the gray. We don't need that.
Gray one.
Okay. Now, what are these? These are this is blue, green, white, red, magenta. This is magenta. This is.
No, you're right the first time.
You're right. This is yellow.
It's yellow.
Okay. Now I need to put them in the same order as this. So blue, green, and then red, and then magenta, yellow, and white. Haha, I only needed to move white. There you go. So now we delete that, and then we change that into commas. Actually, let's make that single commas, like that. And then here, I'm just gonna make that a string and just split it at the commas. Okay. So that's the colors, and then the names are blue, green, red, magenta, yellow, and white.
Really only need the single letters, yeah?
That is a very good point. Okay, blue, green, red. I don't even need to split it at commas then, because I can just use indexing to get these letters. Okay, do you think, can I do this in JavaScript? Remind me of another module where I wrote a recursive solver in JavaScript. What was the task module called? One of the NNMs, the one with the bitmaps. I think it was M and M's.
I think it's double M's.
It's, yep, there we go. So let's take a look at this. Do I have a... Okay, what am I doing here? Function find grid. Oh, this is how I did it. I remember now. Right, here's the recursive call, right? The function calls itself. So what it does is it modifies the grid and then calls the function recursively. And if that is successful, then we can just return it right there. But if not, we need to return false so that the previous call to this will also return false. Bingo. So here is the first recursive call, and if this one fails, then it still needs to try the other possibility and then call itself recursively again. So this is what I'm going to do. So I'm going to have a function find grid. Okay, and we're gonna have a grid.
Does that mean you can set rules? Should that be within set rules?
It was in M&M's. Okay, so we're going to have an array of the same length as how many hexes we have. And I'm going to fill this with nulls. Okay. And no, actually, I'm going to use push and pop like I did in the M&Ms. Okay, so if grid.length is equal to hexes.length, then we have success. Hang on. I'm a bit confused right now. Let me close this and keep this open. So, okay, so this one checks whether there are any duplicate rows. If grid.length equals 10^5, this does some more checking too. And here it says return. Oh, okay. Grids.every. If every grid is, yeah, that's right. It just checks if all of the grids are different. And if all the grids are, so this is the bit that returns true. Yes. Perfect. Okay. Yep. Okay. So we need to add one of the color names combinations at random. So let's see. I'm going to have a random offset. So we're going to say next 0, 30, 36. And then we're going to go through all combinations from 0 to 36, or less than 36 rather, right? But these are just sort of raw numbers, but the actual number is going to be that plus the offset modulo 36. So this way we start at a random number, right? Which in the vast majority of cases that will be the number. But in cases where it needs to backtrack to try a different one, then it will try them in order, but it'll still be random because it started at a random offset. So now I'm going to add this to the grid. No, I can only add it to the grid if none of the previous hexes that are already in the grid, which are adjacent to it, clash. So for let previous hexes equals 0, previous hex. I'm gonna rename this variable later. For now, I'm gonna just call it p to make it faster to type. So I'm gonna go through all of the hexes that are already in the grid, which are adjacent. So if adjacent, I'm going to write the adjacent function in a sec. If hexes of p is adjacent to the hex where I am right now, which is grid.length. If that is the case, then, right, if they are adjacent and they share either the same color or the same letter, then it's not allowed. Do you agree?
Yes.
Okay. So I'm gonna say valid equals true, this and valid. And if our condition fails, then valid equals false, and then if not valid, continue. All right. So, and then here we need to do more. Okay, so what is our condition? If they are adjacent and they either have the same color, so the same color is grid of p, yes, grid of p modulo 6 equals comb modulo 6, or grid of p divided by 6 is equal to comb divided by 6. Okay. How about that?
Yep.
Okay, now let's write that adjacent function. We're going to use the code here, right? We go here. So function adjacent hex 1 hex 2. So var q equals hex 1's q minus hex 2's q. And then var r is equal to hex 1's r minus hex 2's r. And then return. Does JavaScript have a math.max? I assume that it does. Yes, it does. Math.max of math.abs of q math.abs. Oh, I see. Does JavaScript have a 3-value max function? Yes, apparently it does. Cool. So I don't need to nest the math.maxes here like I did in C#. Minus Q minus R. Okay, so if that is equal to 1, then they are adjacent. Okay? Cool. All right. So, right. So we go through all the combinations. We find a combination that that doesn't fail this criterion. In which case we can now push that into the grid. So we put that combination there, and then find out via a recursive call whether this is successful, and if it is not, then return false. Else we need to pop that combination again and then try the next one. Okay, and then when we're done here, we return false. Okay, I think we're good. So now we have a grid. Let false success equal find grid. So this should never say false because we know that there is a valid grid, namely the one that you found. Right. But if this happens, then I want to know about it. So I'm going to say console. Is there a console.error? Console.error. Yes, there is. Bingo. I want that to happen. Error in grid generation algorithm. Okay. Else. Okay. No, I don't want to do that. I want to do this. Return. Okay. So for let I equal 0, I less than hexes.length I plus plus. I promised that I would rename the p variable here, didn't I? P, I'm gonna call it prev index now that I know what it does. There you go. Okay, so now we're gonna go through all of these hexes. The DOM element is going to be document.getElement by ID of, what do I call it, hex that, and then hexes of IQ minus, and then hexes of IR. So that's that. That is the G element, which contains a path element, which will set to the color, and a text element that we will set to the letter. So let's see, glm.find.query selector path dot set attribute fill, and then we want to set it to colors of grid of I. And the text object, now I don't quite remember how to set the contents of a text object. So let's see, so I think it was .content, no, text content. Bingo, that worked, it set it to X. You can see that right there. Alright, so .text content is what it's called. Text content equals names of that. Alright. Whoops. Refresh that. Okay. Did we get an error in grid generation algorithm? Very, very encouraging. Thank you very much. So what happened? What is the easiest way to find out what happened in 16 minutes?
No.
Okay. Let's see.
Oh, did you account for the central cell at all?
I did implicitly, yes. It's just simply not in this array. So it will just.
Hang on. Does the Oh, never mind.
The distance function uses the Q and the R values, not the index in the array. So I could actually shuffle up this, and it should still do the exact same thing. Okay, so let's do console log pushing comb. Okay, it does seem to push a fair few number of things. Oh. Oh, I am stupid. If success, then return true. Else, keep trying. Okay, there you go. That is working slightly better. Let's see. Oh, of course. No, not of course. Okay, that one, go away. Let's look at this one. Path. Fill equals undefined. This is what I suspected. I suspect that the algorithm is working. I just made a tiny little mess here. I just quickly need to wipe something. Sorry about that. So, instead of undefined, we want the correct color from here. And there are 6 of them there. What we actually want is we want the color to be modulo 6 and the name to be divide by 6. Okay, is this working? No. We only have 4 white backgrounds and we have too many red backgrounds. Okay. Yes, of course. I also need to make sure that the combination is not already in grid. If grid dot grid has no includes include comb, then continue. Refresh. Right, rule seed 2, rule seed 3, rule seed 4. Ladies and gentlemen, what do you say?
All right. I'm just checking. It looks good. Wait, what's rule seed 1? So,
if you want me to, I can go and compare that to the one on unfinished.
No, I was gonna say maybe like shuffle it around, and so I want like a lot of the same colors are like clumped together in the rule seeded version. So maybe just like do R&D.next a couple times until it looks. It's just me being picky.
Yeah, which ones though? Did you mean mostly the blues?
Yeah, well, there's a lot of. There's not many. A lot of the reds, greens, and blues are just clumped at the top left.
All right. Okay, so you want me to go R&D.next like that. The white is still clumped, but everything else is better. Right?
I'm just being really picky. Sorry.
No worries.
I just do like.
I think this one's good.
Yeah. Okay, we'll go with this one.
All right. Cool. Now, funnily enough, we're actually only looking at the background colors, aren't we? Like the actual letters B. Let me use the black color.
I mean, that's what I was looking at too. I was looking at the.
Okay, well, this is reasonably spaced out. W's.
Right, it ultimately doesn't matter. But it's just an aesthetic thing.
Yeah.
Yeah.
Yeah, and I would argue that aesthetically, the actual colors stick out more.
Than the letters.
Stick out to you more than the letters do, yeah. Well, anyway, so if you're happy with this, I will now very quickly, I have 11 minutes to translate this into C#. So...
STP will be for another time. It's fine.
So we're going to make this a dictionary hexes like this. Alright, and let's also go here and add KM rule seedable. I wish to put that here. Yes. And then apply a save. And then add a public KM rule seedable. That. And then wait for that to appear here. And then drag that in there.
Oh yeah, it's not 11 minutes, it's 13 minutes because it starts...
I know, I'm saying 11 minutes so that I have 2 minutes to, get to the Discord server, into the VC and everything. Come on, I can't do that instantaneously. It's actually very convenient that they give me 2 minutes to do that. Okay. So rule seed and initialize module. Okay, so rule seed. Var rnd equals rule seedable get rng. Var. I suppose I'm gonna copy this line and remove the var from this one. Right, so I'll reuse that. So except in this case, I want to. You know what? I'm gonna use this to exclude the center this time. Which actually, now that I think about it, I can do that here as well. Now why is it complaining? List of bool. Oh, it's select. I meant where. There you go. Okay. So this will give me all of the hexes that I want, which will be in the same order as this, I presume. I just realized I haven't actually verified that. Shit. Okay, let's very quickly debug.log format hexes that 0 hexes join comma that run.
Throwing an exception because there's no hex info.
That is correct. But let's very quickly look at this, that, and that. Okay.
Same. Yep, it's all the same.
That is actually surprising. Like, you know, I had no idea which way it was gonna go, and it's quite a coincidence that it does the same thing that I intuited. Okay, so back to this. So these are our hexes, which is the same as this, and then we do this. We don't need that. And then we're gonna go var grid equals new list of integers, I guess. Yeah. I'm gonna do that. And then this is annoying. In JavaScript I can I can use a local lambda. Yes, I'm gonna use a local lambda. So func of bool find grid is equal to that. Boink. Find grid. Okay, so I'm just gonna do this because this is never gonna fail. Okay.
Okay.
And then I'm gonna say for int I equals 0 to hexes. I just lost my cursor. Hexes dot count underscore hexes of I is equal to new color info. Now I want the color to be colors of grid of I modulo 6, right? Color is modulo 6. And the other one is going to be color names of, which actually doesn't need an array. I can literally just cast the value directly to CF color. I'm just gonna go that, and we are done. All right, now let's very quickly, I have 7 minutes left to translate all of this. Okay, so if grid.count is equal to hexes.count, return true, replace all let with var in the selection, rnd.next, that one. I think I'm just gonna comment this. All right, so combination if grid.contains. There we go, grid.count. Adjacent, I will need to write. And then this is a single, double, whatever. We don't need the or 0 in C# because C# is a good language. Remove unnecessary parentheses. In fact, we can remove these parentheses as well. There you go. And then we don't need that. In fact, we don't need that here either, that console log. Grid.add success equals, okay. I need to set this to null first. Otherwise it will complain that it's an unassigned variable. Grid.remove at, why did I put comp in here? I just want to pop. Remove at grid.count -1. Alright, everything's back in normal order. Now we make the adjacent function, which is a boolean of 2 hexes, return hex 2 minus hex 1 dot distance. Is that that's a property equals 1. There you go. Cool, huh?
Yeah.
Okay. So what else did I think we're good, aren't we? So I'm going to, here, the goal number 1 is I'm going to output both the coordinates and the color combination. Okay? And the color combination is, of course, hexes of goals of I. Which gives me a color info object. So I'm gonna go here and give this a toString method, which will tell me word dung color dung, and the word is word.toString to lower invariant, and then the color is, oh shit, does this have it? Oh crap. We don't have an easy way to access the name of this color. So I'm going to add that string color name equals color name. And then here we're gonna use color name. Okay, and then here I need color names. And within this selection, we're going to change color dot with a comma in front to this, and then change this to that and that. Okay.
That needs to be a string
array. Very good. And then here we have the color, and then we need the color name of the same value, which is modulo 6. Okay, and then here we can say this. Oh, this is fine. Okay. So let's see. And then here, press yes on that, but the current goal is that. At. Okay, so we pressed yes on hexes of that. And here we want hexes of that. Okay, I think that's it. Okay, right, okay, let's run that. And it's gonna go horribly wrong, isn't it? So let's see. Magenta on green should be at -1, 1. It is not. Oh wait, -1, 1 is that. It's still not there though. Okay, so we messed up. Magenta on green. Where is magenta on green actually?
Oh, do you have your RNG.next at the start?
Pardon?
You have your 2 RNG.next 02 at the start of the C# code.
Oh, yes, thank you. That is a very good observation. I totally would have forgotten about that. RNG, give me that. Okay, like that. And then we need to capitalize that. Okay.
Try it again.
Yeah. Okay, red, green at 3 minus 3. 3 minus 3, red on green. Perfect. Blue, red at -1, -1. Yep. And white, magenta at negative. Yep, there you go. Okay. So let's play Who Wants to Be a Millionaire. We are at magenta on red, which is here, green on white, and then obviously red. There we go. And we need to get to red on green, which is here. So we're gonna press the green, that one. We're now here. Then we're gonna press the magenta on red. And now we are here. Now we're gonna press the red on magenta. And now we are here. Now we're gonna press the yellow on blue, which puts us here. And then we're gonna press the white, which is this one. And now we're here. Then we're gonna press the blue on red, which is this one. Now we're here. Then we press the yellow. And then we're here, and then we're gonna press the magenta on white. Okay, and then we're gonna press the green on magenta, and then we're gonna press the blue on blue, and then we're gonna press yes on the red on green. Bingo. Achieve go number one. Okay, I'm happy that this is working. So with the working module under our belt, we're now gonna move on to the Twitch Place support. I've pasted in the enumerators for the Twitch command and the handle solve. So they are redlining right now because they're methods that aren't returning anything. So I think I'm just gonna put yield break here because I want to test the Twitch Place thing before I start writing the autosolver. So what Twitch commands do we want? Let's see, we want to be able to press yes or no. Which this is for the first stage where you can press either button at any time, and it doesn't need to like wait for a specific thing to happen. Press the button. You know what? It doesn't even need to say that. All right, then I'm gonna say press yes. Oops, yes, no on blue, magenta, or something like that. Press the button when the word blue is shown in magenta color. And then that has a short form, YBM. You know what? Actually, we don't really need an explanation for this. I think this is clear enough. But this, press yes. So I'm gonna write it out here to say what this is an abbreviation for. Press yes when the word blue is shown in magenta color. Right, and then of course we need the reset command. So these are the commands that we're gonna have. So we're gonna use a regular expression match object and check whether the, right, so we need to assign that to M. Check whether the command satisfies the following pattern. So first of all, we want either press or hit or submit or I don't know. Right, okay, fine. And then, of course, you do want some amount of space after that, but all of that is optional, hence the question mark. And then, optionally, we want 2 colors. Oh, right,
You want yes or no first?
You're right. Thank you. We want yes. I completely forgot about that. So I'm going to say, okay, so we want to allow the user to either write out yes, Y-E-S, or have just the letter Y. So 2 of these possibilities, namely yes and the letter Y, I'm going to give this name Y so that I can refer to it later in the code. And the other possibilities are no and N. And these don't need capturing, so I'm putting this question mark colon there to say that we don't need to capture these parentheses into a separate value. Right, then we can have any amount of white space, which actually can go here. Right. So optionally, we want a color on a color. Oh. I just realized, so this is an option between 2 things, but here you really do need 2 colors. So I'm actually going to put a space there. Right, so you're going to have to say yes, yes blue magenta or no blue magenta, right? But not yes blue. That's not enough. So press yes thing.
I also should point out that the example command says yes / no blue magenta, but the explanation only has yes.
Yeah, that's because this example says Y.
Ah, okay.
But I think I get your point. Yeah. I don't know
leave
about
that.
this. Okay. All right, let's leave it like this. Good idea. Okay. So press hit submit, and then, okay, so there's still a space there. I need to be cognizant that I include all the possibilities where the user might want to add a space. Okay, so we want a color. Now, I think we have, we do have a color names array, which I'm just gonna use, and just change this to pipe characters, like that. In fact, I'm going to change these pipe characters to this. And then I'm going to give all of these a name, and then obviously this one. So this is blue, this is green, this is red, this is magenta, yellow, and then we don't need one for white because, if it's none of the others, then it's going to be white. And as I say this, it occurs to me that actually I can just look at the first character of the color. So actually I don't need this. I'm going to remove that again.
I'm not... Oh, you're right.
So I'm actually just going to have all of these. Let's go back here. Okay, so we're still inside this parenthesis? No, we're not. This is the yes, no. Right, we want to be inside of this parenthesis. Okay, so this is going to be the color. So I'm going to give this the name C for color. No, actually, this is the word. It's the word first. Yeah. Thank you. Yes, you have it right. So we want that, and then any number of white space, and then the color. Okay. Now, I just remember that this is a British module, so we're going to change color to the correct spelling there. I'm so paranoid that I'm forgetting, a space or something somewhere.
Right. I think you might need /s+ after every full word written out. Or at least for the colors, or the word yes and the word no.
There is an S here.
That's an optional space for the letter W. But if you're gonna have YESWHITE without any spaces, would that be acceptable? It just seems weird to accept that.
It seems weird to accept that, but if someone wants to type that, then more power to them.
All right.
So yes, you could. At least E is not a color, so just typing yes won't give you, yes on color.
Enough.
So I think it's safe. Okay, so we want regex option ignore case and culture invariant, and so if not null, we want .success. So if this is successful, this match, then we have a command. Now, before we yield return null to indicate that it's a valid command, we first need to check that the module is actually displaying the given combination at some point in the current cycle. So we first need to figure out whether we are in fact waiting for a color. So I'm going to do a color index thing. And we also need to, because you see, in stage 0, I should probably refer to the manual to explain this. In stage 0, it will cycle through 3 displays, but there is a break indicating the end of the sequence. So it effectively cycles through 4 things. And in order to do that internally, it takes the current time in seconds and takes that modulo 4. So I'm going to have a variable that says what to modulo by, and in most cases it'll be 3, but in stage 0 it'll be 4, and then I'll just modify this value. And then this is actually the value that the modulo needs to give you. Okay? If we are currently in stage 0, right. Okay, let's default this to null. Null would indicate that we're not actually waiting for a color, and the user just told them to press either yes or no. So if stage equals 0 and we actually have a... Okay, so I'm checking the word. I could also check the color, right? It's not possible for one of them to be success and the other not. They're either both success or both not success because they're both inside the same optional parenthesis with that question mark at the end. So if stage is 0 and we've specified something, then we want the color index to be equal to, let's see, actually, now that I think about it, we need to determine this regardless what stage it is. If, actually the only thing that changes what stage we, that changes depending on stage is the modulo, I think. Well, we'll see. So if we've specified a color, we first need to decode what color it is, right? Because at the moment, for example, the goals are actually an array of hexes in the hexagonal grid, and we're going to use the hexes dictionary to turn that into a color info. And the color info thing has a color name, and the word. So color and color name refer to the same color, and then color word is the word that is shown in that color. So I just realized here, instead of word.toString, never mind, it does use color name. Sorry, I'm stupid. I was gonna say we could just say color name, but no, the word, okay, I'm confusing myself, so let's go back. So we need to find the color info that has the correct combination. Now, let's see, so the word that we're looking for is mgroups.w.value, take the first character, and then let's uppercase that. There you go. And then the color is that. So now we have the word and we have the color. But what we actually want, is this what we want? I think this is what we want, isn't it? Yeah, let's go with that. If we are in stage 0, then we're flashing the goal. So we're gonna have to look through the goals array. Whereas in any other stage, we'll be flashing the current pos. Now this is a list of hexes, and this is an array of hexes. Okay, so either way, we're gonna be looking through one or the other. So the color index is going to be, well, if stage is 0, then we need goals.index of, find me the goal, whose, like if we look it up in the hexes array, its color name needs to start with, now did we write that color in, I think we wrote that in all caps, didn't we? Because that's what the module shows. Let me just quickly see.
No, I think you did it in lowercase, but you two upper varianted when you change the text. So I think
I'm a little confused right now. It seems that this is never assigned. Oh, there we go. Of course, it's assigned in the constructor. I've already forgotten how everything worked. Okay,
it's
so
lowercase. The only time when it's
indeed
changed to uppercase is when you're changing the text mesh.
Okay, so this is all lowercase, and this one here, this is the enum. So if we toString that, it will start with an uppercase character. So interestingly, I'm going to lowercase the word. Wait, it's called CF color, but it's used by the word. Okay, so the word needs to be uppercase. Oh my gosh. Okay, so the color name needs to, right, its first character needs to be the color character, this one. And its word.toString 0 needs to be equal to the word character. There we go. Okay, so that's if stage is equal to 0, and if stage is not 0, then we do the same thing with the current position. There it is. Okay, I don't think that needs parentheses around the whole thing. Okay, and mod is equal to stage equals 0, then 4, else 3. Which means, I should set this to 0 because if this if this is not the case, if the user has not specified colors, then the code should not use this, right? So if it turns out that the code does use it, we'll get an exception. We'll get a division by 0 exception, and then I'll know why that happened. So it's easier to track down the bug if we do that. So let's see. if the color index that we got is actually -1, then there is no such color combination on the module. So we need to yield break and we need to yield return a send to chat error saying that color combination that word color color combination is not shown on, is not displayed on the module. Let's go with that. There you go. Okay. So now we can yield return null because now we know that the command is definitely valid. Now we need to wait for the correct color index to happen. So we're going to, yes, go on.
Does color index need to be, does the color index need to be nullable?
Well, I am making it nullable because if this doesn't happen, then there won't be a color index.
Ah.
So if color index is not equal to null, then we need to wait. So while this getTime modulo the mod is not equal to the color index, we just yield return null. Okay, we don't even need curlies for that. There you go. And now we're just going to say .value here because it's a nullable. Okay, so this will wait for the correct time. And then when the correct time comes around, we're going to press the correct button. And the correct button is in the button cells array. And if the group Y was successfully matched, which is this one here, then we want button 0, else button 1. Okay. Now, I'm actually not going to do that. I'm just going to yield return an array containing that. Because then the Twitch Play system will automatically do the onInteract and onInteract ended with 1/10 of a second between them. Which...
That is both? Okay.
Yeah, actually there is a bug in this that will happen very rarely. I wonder if you can tell what the bug is. Let me just quickly look at the chat to see if I missed anything. So a forced hull, is that an anagram? Yeah, it has an H and 2 L's. That's
Oh, I was wondering what that message was. Okay.
Shouldn't word be private? No. You're probably talking about this, but oh, I see. I guess I could make them properties with a private setter. That would probably be more C#y. And I'm not getting any compiler errors from that, so yeah, that was probably a good change. All right. So the problem that we have here is, imagine that it is just the end of a timer second. So just in the nick of time, it will still think it's the correct value, and then it will press the button, then the timer changes, and then when it releases the button is when the handler is actually run. So for this reason, we actually need to first wait for the correct value, and then wait again. We need to wait a whole cycle.
Right.
I'm going to put documentation here to say why we're doing this. Wait a cycle to avoid the situation where the button is pressed on the correct color combination but released on the next one. The handler runs on button release. Okay. So in the vast majority of cases, this will, actually not the vast majority, but you know, in 1 out of 3 or 1 out of 4 cases, this will already be false and this will not make a difference. So the only time when it waits a whole cycle is when you were already at the correct color at the time when the command starts processing.
Yep.
Okay, so with that done, we are now going to yield break. Or alternative, we're just going to use else. And now we're going to check for the reset command, which is much easier to write the regular expression for. It's just this. Ignore case and culture invariant. So if this is the case, then obviously you return
you
null.
need a dot success. Oh, you have is match. Never mind.
You are correct. I do not need that because is match just returns a boolean. Okay, so we need to press the no button, which I can do by yield return button cells 1. And then I need to wait for, I'm going to wait for 1.2 seconds. The threshold is at 1 second, but 1.2 seconds makes it absolutely.
Yeah, but don't you have a boolean in your what do you call it, in your timer check thing? And that might be cleaner. I don't know though.
Do I have a boolean in the? Oh wait, what? Sorry.
In your method that checks how long the button's been held for, is there like a boolean that gets set to true once the required amount of time is held?
You want me to specifically set that?
No, does that already exist?
Well, it's not a boolean, but it does check a boolean property. Yes.
Oh, okay. Never mind then.
Right.
I think this is fine then. Okay.
Okay, so what actually happens, I mean, those of you who are watching this on YouTube will already know because it's in the earlier part of the video, but we have this button release thing.
One moment.
This button release thing when you, when you press the no button.
I'm back.
All right. Okay, yeah, that's right. This is what happens, right? When you press the button down, it will start a coroutine called hold button, which is this one here, which does nothing but wait for 1 second. And after that second, it will set hold routine back to null, the same variable that is set to the coroutine here. And then the button release will just check whether that variable is null. So we see that here. If that is null, then it means that the 1 second has passed and we need to do the reset. And in all other cases, we stop the coroutine because we don't want it to still do the reset later. And then we process the non-reset press.
Yeah. So what I'm proposing is instead of waiting 1.2 seconds, you can do while hold coroutine is not equal to null, and then you just yield return null within that while loop.
Okay. That is okay. Okay, fine. While that is not null, you would return null. Okay. I suppose that is definitely something.
That should work, yeah?
Yeah, I think so, definitely.
Right.
And if it doesn't, then we'll find out now because I'm going to test this now. Can this please recompile and the errors disappear? Thank you very much. Now we have a bomb. Let's see, the start position. Start position isn't telling me the color combination. I think I want to quickly do that. Start position is that. Wait. Oh, okay. So what I want, right. So what I actually want is for each of these start positions, this is a list of hexes. So for each hex, I want a string that consists of the color combination and then the location of the hex in parentheses. And the parentheses are already part of the toString, which is why I'm not adding it here. So the color is that, and this is the position. Right. Now let me quickly check the toString method for color info. Yeah, word color, there we go. We do have that. That is specifically there to enable this. So now if I run this, it will say start position is word green color red, word yellow color white, word magenta color blue. All right. I don't really care where that is. I'm just going to press something. And now, you know what? I shouldn't have pressed anything. I'm just going to hold no and reset. And there we have a gap again. Okay, so now I'm going to try and see what happens if I press yes with red on magenta. That seems to have worked. It pressed the yes button at some point. Okay, now let's press yes on... Actually, let's press no, because yes is the confirm button when we hit a goal position. I want to press no on yellow on white.
Okay, it had to wait the cycle.
Yep. And that gave me a strike, which means that we probably, we went over the edge of the diagram. Which means that every other possible press should work. So green on red, for example. Shit, I pressed yes, didn't I?
Yes. Yep.
Was it
no, that's
green
yes
on
again.
red?
That's yes again.
Did I? Shit. Okay.
Oh, so it got stuck.
Okay, that is very interesting.
What was the command you sent in?
So it worked with the yes, but not with the no. Wait, is it because we've already blown up from 3 strikes? I have to try this again. Okay, let's just press one button. And then let's say press. You know what? I'm first gonna try this, and it should say that is not on the module. Okay, that is good. And now we're gonna, let's try it without the word press. Magenta, magenta.
So wait the cycle.
And it worked. I mean, it doesn't output anything when you change your position, but you know, magenta.
I don't think it pressed it.
You're right. Magenta on magenta is
still there, and it.
All right. Let me see what happens. Again, edge of diagram. Pressing the button works. Let's try this one more time. So I want to press no on red and green. Red and green is still there. Okay, why is this not working? That is very strange.
I think it struck you again.
Indeed. Okay, thank you.
I think you were at the corner of the diagram.
Okay, let's press yes on red on red. It pressed it one later. Did you see that?
Did see that. You should probably log what screen is present when it's pressed.
Indeed. Let's do that. Well, where's this called? This is called here, and yeah, this is the one that I want. So, debug, log format. I'm going to use the angle bracket thing here so that it won't show up in the LFA if I forget to remove this. Pressed yes or no. On, well, see, this method doesn't really know what the current position is. No, I should probably check if I did the calculation correctly, because here I just get the bomb info get time, turn it into an integer, which gives me the number of seconds, and then I modulo it by mod. Right? At stage 0, that should be 4, otherwise it's 3.
Are you dividing it by 0.75f?
Bingo, that's what it is. Didn't I have a get current index? I specifically made a method for that.
Oh, does that use mod though?
Ooh.
You need to pass a parameter, I think then.
Yeah, okay. It doesn't need to be a parameter because this method knows what the current stage is. Returns the index within goal current pos, which is currently flashing. So if stage equals, why is this static? This doesn't need to be static. If stage is 0, then we modulo by 4 is 3. Okay. So, does that fully, yes, it does fully explain the problem because we needed to, yeah, so all bets were off. Okay.
I think that's also why the command hung when the bomb blew up, is because the timer wasn't ticking anymore and you're using the bomb time.
That's right.
Which doesn't matter because the bomb's dead at that point, but it's still interesting.
Yes. So I'm gonna say we probably don't need that logging message anymore.
Okay.
Okay, I'm just gonna press something here. Now let's press no on yellow on red.
Has to wait the cycle.
Okay, it did press on the right one. Let's press no on blue and white. Seems to work. Okay, phew. Okay, very good. We now have a working Twitch Plays implementation. Actually, I haven't tested the reset routine yet. Press yes. Reset. Yep, that worked. We now have a gap in the sequence. Okay, so that was the easy part. The harder part, of course, is the autosolver, which needs to find a path through the diagram to the next goal. So, if stage is 0, then honestly we're just gonna press button selection 0 on interact ended. There we go. Okay, so this will just press yes if it's stage 0. And then while stage is less than, let's see, if stage is 1 or 2 or 3, then we're still looking for
it's less than 5
goal.
Less than 4 if you're trying to get to 3 goals, but it equal to 4 if you're trying to get to the center.
Exactly. So we have stages 1, 2, and 3 when we're going to goals, and then there is stage 4 when we need to go to the center of the diagram. But to find the path to the center is probably going to be the same as, I mean, the algorithm is going to be more or less the same, right? It's going to be a breadth first search, like all the others that I always do. So I'm going to say stage less than 5. Okay. Let's see.
Use Dijkstra's algorithm, yeah?
Yeah, the Dijkstra's, the breadth first search. You know, I keep calling it Dijkstra's algorithm, but it's actually a special case of Dijkstra's in which all of the moves that you can make have the same weight or the same cost or distance or whatever you want to call it. And in that special case, it's actually more commonly referred to as breadth first search. So I should really call it that. So what do we need? We need a queue of positions that we haven't looked at yet. How do we
struct?
Pardon?
You need a queue item struct, yeah? And then it has like the current positions. And
but okay, so the complication that we have here is that we're currently representing positions on the grid as a list of 3 hexes, and that list can be in any order, but represent the same position. So we somehow need to find a way to represent the 3 hexes, regardless of their order. What would be a good way to do that? A good way to do that.
Maybe there's some way you can like sort the.
There are 36. There are 36 combinations of colors and words, which means that I can represent a single position as a value from 0 to 36, 35.
Right.
Or alternatively, if you have a 36-bit number, you can set a bit in that number that specifies the specific color word combination. And then you can have 3 bits within the number. So I'm going to
and that doesn't matter. The order doesn't matter, right?
Exactly. So I'm quickly going to write a function. So I'm going to have to use long instead of int because 36 bits is more than 32. Int only has 32 bits. So I'm going to be using a 64-bit integer. And I want to convert color info to num. Right, and I'm going to use that. Okay. Now, one thing that I've been finding quite annoying this whole time, maybe instead of color name, this should really be a number. Maybe it should actually be this enum here. I think instead of a string, this should be a CF color. I think that would make things a lot better.
Yeah, well, that
right?
needs to be.
I'm also going to remove that, and we don't even need that. Because why not have the word capitalized in the logging, right? It doesn't matter.
Yeah. Well, there's going to be a lot of errors now because there's going to be a lot of.
Well, you say a lot of. I think it's going to be only one. Okay, it's about 4. Right, so here, let's see. Colors. Okay, so instead of color names, I'm going to just cast that the same way as I'm doing over here on the right. So that was the first one. Then we have one here. Right, color name of 0. So did I still call it color name? I did, didn't I? Yeah.
Yep.
Okay. So what we actually want is Quinn, you seem to be interrupting me a lot.
String.
No, I'm gonna do this differently. Why don't you let me do this?
Okay.
So I'm going to have a string, color characters or something, right? And I'm going to have these in the correct order: blue, green, red, magenta, yellow, white, like that. And that is a string. And then here, I'm going to say the word is color char's index of. Yeah, that. So we find that index and suddenly we have a number. Okay, and then here we just turn that into an integer, and turn that into an integer. Turn that into an integer, and that. There we go. Okay, now we're dealing entirely with integers.
Yep.
Okay. So we have our color info now. So what we want to do is, okay, so this CI has a word, which is a CF color, so I can cast that to integer, and then I can go 1 shift left that to give me the bit at that position. So I'm gonna do this. Except no, I first, okay, so, I'm getting ahead of myself. When we did this modulo 6 here, the modulo 6 is the, okay, which one is the color and which one is the word? The modulo 6 is the color, and the divide by 6 is the word. So we want word times 6 plus color. So we want the word times 6 plus the color. Color name, I guess. There you go. I should call that color index. Okay. So this will probably fail because I'm using an integer here. I'm going to change that to L, 1L, and now it is a int64, which is the same as long. And if I hover here, you'll see that the shift left operator now operates on longs and returns me a long. So this is what I want. Now I need to be able to get a color info back.
You're missing a closed parenthesis on line 340.
No, I'm not.
Okay.
Long num. Okay, so I've just noticed that this is spelled wrong. And since that was spelled wrong, the file is probably also spelled wrong. And this is spelled wrong.
Everywhere now.
Oh, this one's spelled correctly, only the file is spelled wrong. There you go. Okay. That should be a U, and that should be a U, and that should be a U, and that should be a U. And that should say color index, and that should be a U. And that one is from Unity, so that stays. That should have a U.
Unity's wrong.
Yeah. So we now have a long which has 3 bits, and we need to be able to figure out where those bits are in order to reconstruct the color info. Now, I just realized that what I actually want is I want to be able to turn an array of them into longs, right? So what I actually want to do is I want to aggregate this, start with 0, and then take each previous plus or bitwise or the color info to num of the next in the sequence. There you go. Okay, I may want to inline this if I don't need that method anymore, which is very likely. Yeah, you know what? I'm just gonna do that now. So I'm just gonna do this, and the n, I'm just gonna change that to CI. There you go. Right, because the parameter is already called CI, so let's change it back to n. There you go. Okay, so now we want okay, so we want an array with 3 elements. I'm going to call the CIs. And then so what's the easiest way to figure out the bit position of a bit? Honestly, I think, yeah, we can only do this in a for loop. I can't think of any other way. So we start at bit 0, and then while num is greater than 0, if num and 1 is not equal to 0, then we've encountered a bit. All right? So, oh yeah, I also need the index into the CIS array. This one will, so this one, yeah. I think I can just change that to a for loop. So I'm just gonna iterate over all bits from 0 to 36. There we go. And then if num and 1 shift left bit is not equal to 0, then CIS at that index is gonna be a new color info. Okay, now it expects a unity color as well. I suppose I can technically just grab it from here. So we want the modulo 6 here, then we want this modulo 6, and then we want this divided by 6. There you go. And then we need...
In line 349, you need 1 L.
Thank you. That is correct. Yes. All right. So, so technically, this should work, right? I mean, this will obviously break if you pass in a long that has more than 3 bits set, because then IX will go beyond 3, and then when it tries to write into this array, it will say array index out of bounds. So, you know, if we do get an array index out of bounds error, then this will be why it happened. Okay, so now that we have these functions, we can now have our queue. We want a queue of longs. These are the positions that we still need to look at. And then we need to see which positions we've already visited. And so I just realized yeah, okay, actually this is fine. So what I realized is that for every position on the grid, we need to know what other position we came from, or more precisely, which quote-unquote button we press, as in other words, which position in the grid we need to press. Oh, I just realized this is missing parentheses. See, you don't want to OR it with 1 and then shift left the whole thing.
Yeah.
So this needs to be a dictionary going from a previous position to something like, you know, I usually call it queue item. And I suspect that the queue also needs to know what they, yeah. Let's just assume that for now I can still remove it if I'm wrong. So each queue item needs to know the number that represents the position in the grid, and the number that it came from, and which button it pressed, or rather which combination pressed. Let's call it that.
Why do you need to know which button to press? Isn't it always no if you're traveling?
Well, remember when we did this for mazes, we always needed to know whether you went up, down, left, or right in order to get to the next position.
Ah, okay.
I mean, in some cases, you can easily calculate it from the position, but since the NQ operation already knows which direction it's going, or in this case, which combination it's pressing, it's easier to just do that.
Okay.
Okay. So, I just realized that this thing here where we go word times 6 plus color index, right?
Yeah.
I'm gonna need to use that formula a few more times to convert from color info to number. So I'm actually going to make that a method, or rather a property here. I'm going to call it index, and it's gonna be an int. And we're gonna return this, semicolon, without the ends, there you go. And then we can remove unnecessary parentheses. Right?
Yeah.
Cool. So here we're just gonna say n.index. Nino.
Yep.
Okay. Now, oh yeah, we also need to enqueue our start position, which is color info to num of the current position.
Well, no, you need to enqueue a new queue item.
Mm-hmm.
And then with everything.
That is correct. So the num is gonna be that. The yeah, I'm gonna set parent to -1 to indicate that this is the start position. Now, why is this complaint? It's because current pos is a list instead of, oh, it's a list of hexes even. Oh, this is frustrating. But it makes sense because when you do press the button, it's easy. Oh, I just realized. Oh, gosh. We should not do any of this. We should instead, the queue item should be hexes, I think.
Yeah, but then you still need to you need to know how to sort them then. Because then how do you know what's been visited and what hasn't?
Yeah, fair point.
That's why you use longs, so the sorting doesn't matter.
So I'm going to change that to an IEnumerable of hexes. IEnumerable because then I can do either arrays or lists. And then here I'm just gonna say hexes of n. Wait, is that right? Yes, that's right. That gives me the color info of that. So the question now is, how easy is it going to be to turn such a number back into a hex array? Do we even want to do that? Do we need to do that? I claim that we don't actually need that. We only need the number to identify where we've already been. But once
you also need to check if the any of the hexes are to the goal. And if the goals are hex items, yeah?
Right. You know what? I can just store the actual hex array here. I'm gonna call that grid position. How about that? So the grid position is the current pos, and its number, okay, that is a list of hexes. Ooh, I do need to take a copy of that list because when you press the buttons on the module, it doesn't make a new list, it modifies the list. That is specifically why we made it a list, so that we can easily just remove a hex from it and then add the new one that represents a new position. Okay, so this represents our current position. And then while there is anything in the queue, we're gonna do this. We're going to dequeue an item, and then if visited already contains that item's num, then we ignore it because we've already looked at it. Otherwise, we're going to add it to here. And then we need to find out the possible movements that we can make. So yes, we do actually need this. And we
First
do
need
need
to know. First, you need to know if you've reached a goal.
that too, but yes, you are correct. But I also need this. Well, in fact, I won't know if I reach the goal without knowing the hexes that I'm on.
Right.
So I first need to know what hexes I'm on. So I'm specifically going to make this a list of hexes. Just wait, hang on. Actually, this is an array. Okay, why did I want to make a list? Right, because so the function that we currently have, which determines the position that you can go to, right, specifically relies on it being a list. So when we press no, which is here, no button press, and we are here. So this is the algorithm that finds us the new position. So we need to make this a separate method, which is capable of both either changing the list that we use as our current position or a list that we pass in. So we're just going to pass in a list. So it's gonna be a little complicated because obviously that method is not supposed to output log messages and actually strike you. It needs to return a message saying that you can't go there, right? Wow, this is okay. Okay, so the method that I'm about to write needs to be able to return 3 possible states, right? Either it's success, or you hit the edge, or you hit the center. Let's call that hit edge, hit center. Okay? And if we hit the edge or the center, then we're not going to modify the current position. That's the important part. So let's turn all of this into a method and call it make move. And we're going to pass in the current position. We're going to return a result, move result, list of hexes position. I'm going to say current pos here and then rename it so that everything gets changed. Why is it still complaining? Because it doesn't return a value. That is correct. Right, and we need, right, let's call that cur index. And then we pass that in here as the current index. Now, if opposite or length equals 0, then we attempted to go over the edge, so we return edge. And then we say, oh, right, we do need to do this position.insert in order to restore the list to its former glory. And then here we're going to say if result equals hit edge, then that needs to happen. Okay? Yeah, this is correct. Else, if any of this happens, okay, so the stage 4 thing, yeah, so if this happens, okay, so I'm going to restore the position regardless, even if we did solve the module, and then we say we hit the center, and then here, else if result equals hit center, then if that is the case and stage 4 is active, then that should happen. Else if that is the case, then that should happen. Okay, I think this is correct. And then finally, in all other cases, so since the others have return statements, I can do this. Position.add opposite 0, return success. So in that case, we don't need to do anything else in here because, you know, the method wasn't doing anything else. Okay. So we now have a method that can make a move on any position. Now, I believe that this method doesn't actually use any fields. And indeed, I'm not getting any red lines. So I'm going to make it static just to, indicate that I want that to be non-static.
Do the moves end up getting made?
Yes, this is what the position.add does. It adds the position opposite on the triangle.
Right. Okay.
So, let's see. We want this to be a list of hexes. And then here we have our color info, but actually I'm going to say hexes dot, so I'm going to find the hex that has the following property. In fact, no. I'm going to find the key value pair where the value, which is a color info, has the same index as bit, right? And then once we found that, we get the key, which is the hex. And then instead of assigning this to an index, we're going to add that to the list, which means we don't need that index anymore. And then we don't need these curlies anymore. There you go. So this feels to me a bit performance intense, but hopefully we won't need to do that. I mean, there are only 36 hexes in the grid, so we necessarily only need to do that 36 times for every move in the path. So it's going to be fine.
I still have a question about like the no press method that you changed.
Right.
Like, it may check if it's a success or a fail, but on a success, do you actually get moved?
Yes, because the make move function actually modifies the list that you pass in, and we are passing in the current pos list. So that list does get changed.
Oh, I didn't know you could modify a parameter today. I learned. That's like the dumbest thing. Yay.
Well, you know how C# distinguishes reference types and value types. A reference type is something that you pass by reference, so you're modifying the same object. And a value type is something that you pass by value. So for example, int is a value type. It gets copied when you call the method, and also when you assign variables.
Okay.
So in fact, you'll notice that I have this coloring here. This is orange because it's a reference type, and this is blue because it's a reference, because it's a value type. So hexes get copied, lists don't. Okay, so now let's get back to our Dijkstra's algorithm here. So we can now check whether the new position, yeah, that's right. If the items hexes, no, what did I call it? Grid position. There you go. If that contains the current goal position, which is goals at stage -1, then we're done. Okay, and now we need to find out all of the moves that we can make. There are always 3 possible moves, so let's call that move index. There are 3 of them. Let's get a result. Make move item dot position grid position. Now this is an array, so I need to turn that array into a list. Whoops. And then tell it to make the move at this index.
Right. Your list is called Olst at the moment.
No, it's List for list.
Okay.
But okay, fine, I'll change it to pos. There you go. Now, depending on the result,
that's actually that I didn't know existed.
Actually, we don't care about any of this. We only care if the result is successful. If that is the case, then we want to enqueue a new item where the new grid position is now pos.toArray because it has now changed after the call to make move. The combination pressed is equal to all. Yeah, okay, I still have the old item grid position, so I can just do that. And this gives me a hex. I see. Why did I make this an int?
You know what index to press it at. but you can just check that
Yeah,
later.
I can. Should I change that to hex? I'm gonna change that to hex. Because I can easily look up the combination from the hex by just using the hexes. You know, I can just go hexes of that hex, and that will give me the color info. Okay.
Right. You're not setting your parent, though.
No, I haven't closed the parenthesis yet. Jesus. Okay, so my number is now position to number. What did I call it? Color info to number. Which is wrong because I'm not passing a color info anymore. So I'm going to have to rename this. And I want to pass in the new position, right? Which is pos. Yes. And then the parent is going to be item dot num. There we go. Okay, so this is position to num. And this is num to position. We haven't needed this yet. I strongly suspect that we won't need that at all. No, that's right. We need that at the end when we perform the series of moves, which in fact we're going to do right now, aren't we?
Yeah.
So the last position is the one that, you know, this one. So I need the number for that. So var goal number. I'm going to set that to -1 long. There you go. So that it will definitely throw an exception if something goes wrong. So I want to look that up in the visited array of goal num. In fact, I forgot to assign that right here. That is equal to item.num. Okay. And then while p.parent is not equal to -1. So we need our moves, which is a list of hexes. The hexes that we need to press.
Yep.
So the parent is going to be visited of p.parent. And then we add the combination press is now hex pressed. Yes. And then p is equal to parent. I think I can just inline that. There you go. Nah, I don't want to. Okay. Is this correct? So let's say we are already on the goal position, then p.parent will immediately be -1.
Well, you need to check if p.parent's equal to negative. Oh. Okay, I see what you're doing. Never mind.
Okay, so if we're already on a goal position, on the current goal position, then p.parent will immediately be -1, so we have no moves to make. If we are 1 away, then the list will contain 1. So now we're just going to go backwards through that list, which is moves.count -1. And that, okay, thank you. That move is a hex. So we need to wait for that hex to be highlighted on the module and then press the no button. Right?
Yep.
How do we, okay, so at which index do we need to press? This is current position dot index of move. That's right. And then while current index is not equal to index, you'll return true, I suppose. And then button cells of 1.onInteract. Now this time I'm not gonna do the, wait for another cycle if you're on it, because I'm just gonna make it instantaneous and it'll be fine. Okay, and then at the end we need to wait for the goal. Yeah, so the goal index is where in the current position do we have a hex that is the goal hex at stage -1. And then we need to do exactly all of this again.
This is only for stages 1, 2, and 3. Stage 4, you're not going to require this last part.
That is correct. Okay, so I'm just
also,
going
that
to...
needs to be button cells of 0 in line 394 and 395.
Thank you. Okay. So I know that this is not complete. It will not go to the center, but I'm going to run this now and just to see if it works. Or should I try to do the whole thing? You know what? I'm going to try to do the whole thing. Because it's going to be even more glorious if it works at, first try. Which it won't, obviously, but...
Oh, of course not.
Actually, the other day I wrote an algorithm for our puzzle hunt that we're in. And it worked first try. Yeah, that's me bragging. Okay, so, let's see. Right. Okay. If item.grid position contains. So this is if the current stage is less than 4. If the current stage is equal to 4, then we need to do here else if stage is equal to 4 and result is equal to hit center. Then the goal num is equal to move index. Break. No, that's nonsense. So the item that we're currently on has been added to visited. So it's actually item.num, isn't it? Yes. Because the num here identifies the position in the grid. So what this will do is it will navigate us to the position that is closest to the center, right? It doesn't actually perform the move that takes you into the center. So we will still need to make that move, right? All this does is remember that this position is possible. In fact, we can... I have an idea. So in all the other cases, like where stage is less than 4, we're not going to use this variable. But in this one case, we're going to set the goal hex to
You need to make a new hex. No?
That.
Yep.
Okay. Right. Okay, so we will do all of this. This will do the sequence of moves up to where the Lecture's algorithm ended. And then if stage is equal to 4, well, let's say it's less than 4.
Yep.
Then let's do that. Else. So if it's equal to 4, then we need to wait for goal hex. So we're doing pretty much the same thing as here, except that the goal index is now index of goal hex. And the button that we need to press is 1.
You don't need to press anything.
No, you do. You need to make the move that takes you onto the center.
Ah.
So,
isn't that already done above though?
As I explained, no.
Oh.
I mean, yeah, see, the thing is, if result is equal to hit center, then the move will not have changed, because we actually don't have a way to represent a position that includes the center. Because we only have 36 hexes that we represent.
Hang on. No,
No.
but in line 389 down, you're just pressing no a bunch of times based on the moves. So you're already traveling there.
Yes, I'm traveling to a position that is next to it. The last move that moves you onto the center still needs to be done after that.
Ah. Okay.
Okay. Now I'm going to move this here outside of that if, and I'm going to say if stage is less than 4, then it's this. Yeah, otherwise this. Oh, I see. I can actually just put that in here. So it's either this or goal hex. There we go. Then this can go. And then this is going to be the same for both. And then I'm just going to say if stage is less than 4, then we press 0, else 1. And there we go. Okay.
Yep.
Now,
First try.
Now we will try this. And I have no confidence that this is going to work first try.
No, neither do I.
Solve bomb, here we go. You know what, before I do this actually, we should we should make it log when you make a move.
Okay. So it's easier to track. Oh, I don't think I have HTML.
So here I'm going to use the angle brackets again, and I'm going to say moved to position. Okay, so this is current position. Okay,
I don't have access to the HTML with the main. It's not in the source code.
Yeah, don't worry about that. I'll push it to KTANE content.
Okay.
Okay, so this will hopefully log the movement. Okay, so let's see if that works. I'm just gonna press a button. Our start position is green on blue here. Blue on white, which is here. Of course, it's right next to it. I'm just not made for this.
And red, which is to the right.
So let's press the blue on white. Aha.
Yeah, format exception.
It's it's the log message, isn't it? Yes. I am very intelligent.
Yes.
No. I'm pressing no. I just pressed no. We are now on white, yellow on yellow, and blue on red. Yes, blue on red. So we're gonna press white on white. And we've moved to yellow, blue, red, and magenta, white. Okay, that works. Okay, so the logging works. And now we solve bomb. Ready?
Yeah, I'm just gonna say key not found or something.
Or it just does nothing.
That's also an option.
Okay. So we need to first of all make sure that the that this even gets called.
Wrong method.
Wrong method. This one. And then let's also see if we get to here. Okay. Yeah, I suppose I can just do that. Okay, it did hit both of those. You know, maybe it's actually pressing buttons and we're just not seeing it.
No, the screens aren't changing.
Yeah. It did press the first key though to get out of stage 0. Yeah, it just presses yes once. Okay. So let's see what yeah, let's just move this here and see what the moves list contains. Join. Let's just try that. It does contain a series of moves. Right, okay, that means that it is stuck here in this while. Current position index of... Right, okay, if that gives us -1, then this will just wait forever. So the move, I'm going to here. Okay, so current position, trying to make move 1. So the current position is that, joined with semicolons, with commas, and I'm trying to make the move of move, which is here, which has a position. Wait, move, yeah, move is already the position. The color thing is hexes of move. There you go. Okay. And now it says keynote right. Move is not in hexes. God damn it. Okay, fine, then let's output just that. Okay, so our current position is this, and I'm trying to make move 0, 0, so it's just, right, hex pressed. I do specify hex pressed here. But not here. Which, yeah, okay. Yep, this is the problem. This shouldn't be parent.hexpressed, it should be p.hexpressed. Obviously.
Yeah. Oh. No way.
Well, it's making moves, but oh, there you go. Achieved goal number 1, achieved goal number 2.
Your audio is missing from the test harness, but that's okay.
Input correct.
Achieved goal number 3.
Module solved.
Wow.
Did you notice that it made like 5 moves instantaneously because, you know, because it was the correct index on the timer? Maybe every time we do this, we should you return you wait for a second 0.1 just for good measure. Yeah, let's do that. Okay, and now we're gonna 1, 2, 3, 4, 5, 6, 7, 8. That should be enough.
You can add this. Okay.
Wait, it said variable mod is assigned, but its value is never used. Does it mean this one? Yes, because get current index already knows the mod. So I don't actually need this variable. See, that warning was correct. Let's see if there are any more warnings. Please recompile.
Sound in the test harness?
I will do that in a sec. Color names.
Yeah, that makes sense.
Right, because we're now using integer indices. Okay. Right, so you are telling me to go here, open up audio clips, and put this here.
Yep.
Okay. And now we run this. Oh, why is this the wrong number? Right, because there's one too many. There we go. Solve bomb.
Getting a lot of presses. Oh, it was almost first try. But you changed one thing and then it worked, so we'll call it first try.
Well, it's obviously second try. I don't know what you're on about.
Yeah, no, but the fix was minimal. Like, you didn't have to rewrite anything, so we'll call it first try.
But you say the fix was minimal, but finding the fix was not minimal. Like, I needed a log message for it.
Well, we got ourselves a Decolour Flash.
It does not play a sound when it's solved.
Yeah, it plays the correct chime, which you can't hear.
Which, no, it does not do that right now. So I want to fix that.
It should. Yes, it does.
It does. Did you add that? I don't remember
yes, I
putting
did.
that. Yeah, very good. That's my man. Okay. So, what else do we need to do?
Should probably maybe try and solve one through TP.
You want me to run actual TP?
No, just load up the manual and just like use the TP commands in the thing, just to make sure.
Oh, solve one using TP commands. I see. Well, what I was gonna do here right now is generate the PDF and then perhaps upload it. But okay, I guess I'll do this first. Let's go here. Run this. Okay. So
Use the PDF. Forgot I had access to that.
Do you mind if I use the logging to know where the goals are?
Yeah, that's fine.
Okay. So we're at red and green, black color, magenta and magenta, and white, that one. And we're trying to get to blue on white, which is here. So we're gonna press red on green. So we're gonna know red, green. And then we should be here. Then we're gonna press blue on, no, white on blue is what it is. And then magenta, magenta. And then white, whoops, white on green. Yep, that is correct. Is this? Yes, this is the one. So we need blue on yellow. Okay, and now we need to press yes on blue on white. Doodling! Alright, our next goal, I should have removed that log message. Our next goal is blue on green, which is here. So red on red, and green on blue, and blue on white, and green on green. And then yes on blue on green. Ah, tiny bit too late. Okay, and then final goal is yellow, white. Yellow on white. Am I blind? Yes, because I'm already there. Cool, so I just need to press yes on yellow on white. Again. Alright.
Press no on yellow and white.
Indeed. Alright.
Wow.
We've done it. Okay, I'm gonna remove that one log message here, which I don't want. And
Yep.
Okay, so I've just regenerated the PDF. So now I'm going to press F6 to recompile this. And I haven't looked at the chat this whole time, which I want to do here. There has been literally no messages in the chat the whole time. I guess that means no one's really watching.
Is anyone here?
Probably not. So I'm going to upload this. So we've already uploaded this before, which is why the Steam ID already exists, but I haven't made it public yet. So added TP and TP support and autosolver.
Oh, RobJS has been here.
Hello, RobJS. No one's been here, but I was wondering, is there a Decolour Flash manual anywhere? Well, it will be on the repo in just a second. I'm going to upload that literally right now. So, first of all, let's stage all of this. And here is our Twitch stuff. Here's our make movement method. And all of the changes from color to color. Yeah, all that is good. Right, cool. So add TP support and autosolver. Push that. Okay. Yeah, I guess I'm gonna publish that now, right? I'm just gonna, oh, wait, did I already upload it? Yeah, I already uploaded it, cool. All right, I'm now going to go to the KTANE content repository where all the manuals are. And this has the manual already here. It has the JSON, which I've written while I was offline. And
publish date needs to get changed.
Publish date, thank you, that needs changing. I was just gonna say that the symbol DCF was taken by Decolour Flash, so we've decided to change that to DICF and DECF, which is what discolored and decolored squares already do, so this is consistent. All right, let's copy this path and open it in Notepad.
Ooh. Does the JSON say that rule seed is supported?
Very good. That is also something I need to take care of. Okay, that is 31 now. Sure. Pick a module, rock, paper, scissors, lizard, Spock. Rule seed support supported. PQR, that goes here. And we're done, I think.
Yeah.
I mean, we could still add souvenir support, but maybe... Wait, why does it say type red? Oh, I changed re to D because I was modifying Decolour Flash. So
it's a regular module.
I'm so glad I noticed that.
Make sure that doesn't exist anywhere else.
Yeah, it doesn't. I'm scanning it here. Yeah. Okay.
So what difficulty do we want to set to these?
I think we already discussed this off stream, but yeah, it's easy for the diffuser because they only need to press the right button at the right time, and the expert just needs to.
That's fine.
It's medium. Okay. So we are now going to. But before we do that, we should publish it. So here's the Steam Workshop entry. As you can see, it says current visibility hidden. So I'm going to change the visibility to public. And now I'm going to wait a few seconds. In fact, I don't even need to wait a few seconds. I'm going to delete this from my mods folder and then subscribe to it. And then also close Unity, because I won't need that anymore. All right, Decolour Flash manual, commit and push.
I've already done the appendix, by the way, so you don't need to worry about that.
Awesome, thank you.
And Brian has already done the icon, which was already on the repo.
Wow. There it is. If the display cycles through 3 colors with a gap. With a gap, though, you know.
Yeah, well, Decolour Flash has 5, so I just kind of left it there.
Now I have to make a module that cycles through 3 colors without a gap, just to make you do.
Yeah.
No, I'm kidding.
And then it needs to be called Anti-Color Flash to make sure to ruin the alphabet order.
Here's our new module, Decolour Flash, and the icon is there. So thank you everybody for watching, and I'll see you next time. See you. Bye bye.